Right onto the glass, guys. Let me introduce myself in very short, right? So I'm Sohail, right, and I am a senior technical trainer here. Okay, I'm a senior technical trainer, and I look into courses like CCNA, CCNP, NCore, okay, CCNP, NRC. I look into CCNP security. That's basically the ESCO, right? What we are doing right now. So that's our course. Uh, Also, some other firewalls and stuff like Palo Alto and like things like that. But we have some operational challenges with those things. But ESCO is like a bunch of things. And anyway, we'll discuss the ESCO in a while. Okay, what else? So apart from this, of course, I look also into data science and stuff. Right, have a have some certifications in this regard, and also look into courses in this regard. Right, so I mean those programming languages like Python, R, and all of those things. Cool, right? So that's about me. Now, this course that we are looking into, of course, is the ESCORE course, right? Which is actually, I mean, like this is specifically named ESCORE. However, with Cisco line of things, if they were to rename it in some other way, this would probably be CCNP Security, and that is what it is, right? So it's CCNP level of the security course. Now, why a separate course? By the way, like so Cisco has been aiming for the Cisco industry. I mean, to get pretty large in it for a pretty long time, right? And they have been, acquiring companies left and right, right? And they want to make a name, a huge name in the in the security business, right? And they are also much looking into that, right? And recently, I mean, the most recent was Splunk, right? That they kind of acquired, and yeah, I mean, possibly like one big news from them, and they probably will have a huge market share eventually. Okay, possibly that is what I feel. But right now, yeah, I mean, like these are pretty similar devices all across uh, the landscape. I mean, with let's say Palo Alto and Firepoint and Checkpoint and like they are basically kind of very similar products out there, and therefore there's no clear market winner as of now. I mean, you have very similar market shares, for example. Okay, nobody is like beyond like 25%, 30%. It's a very fragmented market, is what I would say, which is kind of a good thing, right? And you possibly do not know like one single feature somewhere down the line, and somebody would capture the entire market, and possibly it could be a giant like Cisco, right? It very well could be. But anyway, that is what ESCORE is all about. That is what basically ESCORE is. This is CCNP security. This is what you kind of expect out of it. Essentially, ESCORE basically technically means like you would be implementing and operating Cisco security core technologies, right? So you have Cisco security core technologies, right? That is what this is all about. Now, so what is all of this ESCORE thing all about, right? I mean, like, what can you expect out of all of this? See, so the thing is, Cisco, like I said, has been going left and right, and they have been trying to acquire different companies, which of course they have, in fact, and they still are doing it. And so what they have right now is a huge landscape of security devices. Okay, I mean, of course, people who work with it, they would know, but then that is what it has come to be. Okay, it has a very large landscape of devices with a lot of things, by the way, right? There are a lot of things. So for example, even with firewalls, there is something called as the adaptive security appliance, which they keep on saying is going to be end of line and like stuff, but because of the market share that it still has, Cisco just keeps it operating online, right? So ASA is like a firewall. It's also a new generation firewall, and it is there. It is there, and it just keeps on running. Although Cisco has been saying for a pretty long time that they will be taking it out, but it's still there. It just goes on and on. Then you have firepower. right? Firepower again is a firewall, right? Now again, now some people would say like, why does the same brand or the same vendor have two different firewalls? For the same reason, right? I mean, like I said, I mean, they have been acquiring companies, right? They did not make these devices from scratch, right? If they probably would have, then maybe the features would be very segregated. But that is not the case, right? They have been going about acquiring like devices and companies and like that, and uh, that is what has uh, made this as a uh, uh, as as devices probably which also overlap in features, as you will see, right? Many devices, you will see that they overlap in features. For example, AS and firepower are literally firewalls. I mean, the same vendor having two firewalls is kind of odd. But yeah, then that is what it is, right? That is essentially what that is. So you have ASA, you have firepower, which are essentially like generic firewalls, as you would kind of expect for what a firewall to be. And then you also have things like the web security appliance, okay, which is very targeted. It is, you could treat all of this as security devices and firewalls. The WSA, or the web security appliance, is particularly like a thing that you only have for web security, okay, meaning like of course your organization would have employees who want to browse the internet and stuff, and you want to give them a secured environment, right? So WSA comes in that part. Now that is not to say that AS and firepower cannot do it. Of course they can, right? But you have additional features, and this is a very targeted device specifically for web security. Similarly, you have something called as the ESA. Okay, now ESA is specifically for email security, right? Every other organization, deals with a lot of emails and stuff. Of course, you have those things in place, and yeah, you of course want to probably secure them as well, right? I mean, uh, there are many organizations that put emails in and out during the day, just non-stop, and you have phishing and whatnot going on in the industry, right? I mean, a lot of things being compromised just because of emails. Also, you want people not to share sensitive data outside the organization on like in emails or like stuff. You so there are a lot of things, right? I mean, this is where the ESA comes into picture, right? So you have a bunch of devices, and that is why you have this entire course and this certification around it, right? That is what basically an S-core like kind of is all about. And of course, with it, although VPN is not a separate thing, VPN is something that you deploy like within the firewalls and like stuff, right? But yeah, I mean, again, you have VPN and those kind of things that you can do on these devices, right? To help you have a secured network. So yeah, this is essentially what S-core is all about, and yeah, like this is what we'll be learning about in the course. Okay, now, yeah, still some basic details in the introductory nature, because although, like Nitesh said, I hope that you guys already are aware of all this, because, but I don't know, maybe like somebody else has still not joined in and they will be probably watching the recorded session. So maybe it is for them, okay? Please bear with me while I have some introductory like stuff information be given to you about the nature of the course and what all can you expect. So this is the S-core course, right? I hope everybody is in the right place. Please do note our batch code, which is 4063. Please ensure that you're in the right Telegram group and stuff, all right? And also with the links and like stuff, this is 4063 S-core, right? This is your batch code. Please keep a note of it just in case. I mean, so you know whom to connect with, and like in case you want to do that in case, right? So that's basically that. This is a weekend course, right? And with weekend, what I mean is you have Saturdays and Sundays. Okay, so 2 days. What you will have is on Saturdays and Sundays. This will be at 5 p.m. IST, right? So in case you are joining, from another time zone, please check the conversion times, right? This is 5 p.m. Indian Standard Time, IST. All right, give or take like 5 minutes. We'll wait for other people to join sometimes, because we'll have to be a little, tolerative, because you have people joining from different time zones. Maybe somebody's waking up in the middle of the night or like something like that. So you just give it maybe 2-3 minutes for them to join. But otherwise it is going to be a 5 p.m. sharp thing IST. Now the duration of the course, the duration of each session, okay, the duration of each session uh, is a maximum of 3 hours, but we'll try to wrap it up a little early, okay, given that this is a weekend. And again, like I said, there are people joining in from different time zones and like stuff. We will try to wrap it off everything between like 2 to 2.5 hours, okay. I'll try to do that whenever possible. Sometimes it may take a little more, again depending on how labs behave and like all those things, as you probably are well aware of, right, in case you are already accustomed to this thing. But I'll try to wrap it off everything like in 2 to 2.5 hours. The duration of this entire course, I'm expecting it to be around 15 to 18 days probably, okay, all in all. I mean, like this is like the first day, right? So like that, you possibly can expect it to be like 15 to 18 days. And yeah, like that's what it is going to be like, right? So 15 to 80 days is something that we are looking into. Again, we are not very stringent on that. I mean, it's not about rushing things. It is about people understanding stuff, and this is what it is all about, right? Now, of course, with any course, okay, with any course, not even this, anything that you do, of course you need some support systems, right, uh, to help you tackle the course, okay, like in a way. So what all is available at your end? Let's kind of have a look into this. So your basic coordination, whatever it is, okay, like in terms of like basic communication, or maybe like, so for example, let's say someday you cannot make it, or maybe you're late, or I don't know, maybe you want to inform something, or maybe it is me who wants to inform something. Maybe there's a technical glitch at my end. These things keep on happening. God forbid that they happen, but let's say if they do, I would of course have to inform you or the entire team. I'll do that on the Telegram group, right? So I hope everybody is on the Telegram group. Again, 4063 is our code, right? So please ensure that you're in the right group. In case you haven't received the invitation link or whatever it is, please reach out to Nitish, and like he'll help you join the correct group, right? So Telegram it is. All the information, all the things that we'll share, okay, will be on the Telegram group. Now this session, like all of the sessions, would always be recorded from start to end. Okay, so you'll have recorded sessions, which of course I believe everybody has to go through at least twice, thrice to make sense out of it. I mean, for example, if you are new to security, okay, as a whole, I would be expecting that, and any which ways, I mean, even if that were not the case, uh, you cannot expect yourself to remember everything in one go. You possibly have to revisit the video sessions. This being a weekend class, it is good for you that the weekdays you can utilize, to to maybe revise or maybe go through the sessions. So these sessions are being recorded and they are available on a platform, by the way. Okay, so these are not shared as uh, uh, they're not shared as links or anything, right? So they are on a particular platform where you log in with credentials and stuff. Again, if you have been in some other course, you possibly know this, right? So this is Thinkific, as it is called. Yeah, so it is basically Thinkific. All right, so this is essentially something called as Thinkific platform, and the credentials, by the way, would be on your email. Right, I don't shoot out actually the credentials. So in case you haven't received them, you might want to reach out to Nitish, and he'll help you, get those credentials. If you already have it, like he said, you will be able to see those things in your own portal, as you have been already enrolled in the uh, like some other course, right? So you will possibly see them there as well.
So like I'm
Yeah.
new actually, so I don't have the like the portal link and also. I'll
Yeah,
reach
no,
out
no
to
worries. So
Nitish on
that
that.
will possibly, so
Hmm.
yeah, that was just getting to that. So basically, maybe like this is the first day, you don't have it in your email, maybe, okay.
Hmm.
I'm not sure. In case, however, you do not receive that in like 2 or 3 more days, please reach out to Nitesh and tell him that maybe you need the credentials, correct? So please ensure that you have those credentials. They'll be like separate usernames and password and a link, right, for the Thinkific platform, as it is called. and you can log in there and you'll see a day wise recording, right? So it's a very sorted place where you can, but ensure that you get it in like within a week or like so, right? I
Mm.
sometimes hear students that they do not know how to log in, or maybe they're not even aware of the thinkific stuff,
Yeah.
like even after like weeks, and like, so don't let that happen. Okay, try and get it as soon as possible so that you can review the sessions, which I think is a basic necessity, right? I mean, having
Mhm.
heard about things in like one go, I don't think anybody can remember things like that. By the way, these sessions, right, themselves, I'm not sure of like the timeline, but I'm guessing that they, again, this is not something that I do, as somebody in the back end kind of does it. So I'm assuming that it will be uploaded by the next day or something, right? Given this is a weekend class I have. Again, I'm not really sure, but yeah, it will be possibly like by the next day at least, right? So give them a little time.
Mm.
They will be uploading this on the next day, I guess. Now,
Sure.
yeah. So that's basically that. And any which ways, I mean, whatever it is, you can always communicate, and things would be resolved any which ways, right? We already have this going on endlessly, so there is not much that goes wrong. But yeah, in case if somebody has missed out sending the credentials or like something, it can happen, right? Always also check your spam and like stuff. Sometimes it ends up there, and please ensure that you like get those things there. But in case not, I mean, please reach out to somebody. Do not hesitate, and get it sorted. Correct. Now, what else? So recorded session is one thing. Whiteboard. So right now I'm using this whiteboard, right? So yeah, I'm having some trouble with the licenses and stuff, and this is at the moment I'm not really fond of this thing. And I'll see if I can use a different software to make it a little more worthwhile for me, and for you as well. But any which ways, this is the whiteboard or something like this, and like a per day thing is something that I will be sharing as a PDF with you in the group again, right? So in case, so these will be of course scribblings. This will be the whiteboard notes, all right? Simplified stuff, right? Where you can just go and revisit maybe what happened in the class, and you want to just look into these notes kind of stuff, right? So this is kind of helpful. I will be sharing the PDF files like on a per day basis. Okay, so I'll try to do that as like, in fact, on the same day itself, right? As the course ends, I mean, as the class ends, and I'll be sharing the PDF file with you. So that will be better, I guess, right? So you'll have the PDF file in case you want to have a look at this whiteboard thing. Okay, so that is there. However, um, a much more sorted thing would be some actual notes in PDF, and of course we have those as well. So you'll have notes, right, in proper like PDF stuff, printed PDF stuffs, and I will share them as per like topic wise, right? So let's say we cover a topic, we end the topic there, and I will be sharing a PDF file. Uh, Sharing everything in one go does not really work. Nobody like then reads it, or like I don't know, maybe like some people find it overwhelming or like something. So out of my experience, sharing things and bits and pieces kind of helps. Okay, so I'll try to stick with that, and you can have those things. Now, so this is of course with regards to theory stuff, right? I mean, notes is theory, whiteboard is of course theory, but much of our course, of course, is going to be practicals, right? I mean, of course, we'll have labs and all those things. In fact, most of our course is about all of that, right? You have some theory, of course, but you also have labs, right? More of it to actually execute stuff. Now these labs will be executing in our EVNG thing, in the remote thing, and possibly I think you also have some kind of an access to some remote lab, I guess. So yeah, I mean, you can execute the same things over there. I will be sharing uh, like for the lab stuff, I'll be sharing the topologies with you. Okay, and I'll help you understand how to get it uploaded at your end. Okay, so that you have the same topology as I do, and you can execute the same stuff. And I will also have some pre-configurations be given on that, so that you don't have to sit and do the entire thing. Meaning, for example, let's say our topology has uh, probably routers, right? And you have firewalls, of course, as well. Now, routers probably in this course at least is not the core focus, right? So I'll ensure that I'll at least I'll try that you have the routers pre-configured and again, you can choose. I mean, you can choose in case you also want to configure the routers from the beginning, right? In case you want to do that, that's also possible. But any which ways, I'll be sharing those topologies so that you can upload it to your EVNG and you'll have the same like stuff going on, right? So that is something which will be shared. Apart from this, there'll be something called as lab guides. Now, what are lab guides? Lab guides are basically PDF files that help you uh, execute the labs themselves, right? Because again, when you execute the labs, you might need some reference, some things going on, right? You might not be, because out of your mind, be able to remember stuff just in one go, right? So lab guides are those PDF things that will help you execute certain things, right? So yeah, the lab guides of course will also be shared with you, like as and when, right? When we complete stuff again in bits and pieces, that is kind of better, I guess. So yeah, so this is like the initial uh, setup, right? This is what you basically kind of expect out of this entire course, right? I hope everybody is clear with this. Any doubts, any
Uh,
queries so far? Anything at all?
Um, like labs, like we'll get a link as well separately, or like how we can access the labs.
The labs would be actually as a link. I mean, there's a website for that, and you log in and you get a remote PC. Okay. Now, wherein
Mm,
you start your EVNG and you will have your own pod, an EVNG pod, and you can execute things over there, right?
mm.
So, any which ways, I'll guide you when the time comes. I'll help you
Yeah, sure. Like
also.
when you're
Yeah, yeah,
doing
yeah,
it
yeah,
live,
yeah.
then we
No
can do it
worries.
side by
Yes,
side
correct.
along with that. Yeah.
Correct. So
Mm-hmm.
that is essentially like how it will follow, right? So
Mm-hmm.
that's basically that, and I'll guide you when the time comes. Certainly, I mean, just like that, you would not be able to access and like do the lab part in case you are not already aware of something like that. But yeah, no worries. I will help you in this regard as well.
Yeah, sure.
Correct. So yeah. So this is basically uh, like all about that. Okay, this is basically the basic introduction setup, right? So cool. I guess let's begin with. So this is the first day. Of course, we'll not overwhelm ourselves again. There are some people who haven't even joined. Okay, so any which ways, I mean, see the course. This is the course where I mean it is not a plain practical course, right? I mean, what we are aiming to do is, and some of you and some of our students even in the past have opted to get certified, right? I mean, after attending this course, and they actually got certified, right? So maybe you also want to do the same, but then when you do that, apart from the practical skills, you also need a good theoretical background, right? Otherwise, I mean, of course, certainly you cannot. So you may have the knowledge of configuring stuff, but theory and how things work is a whole different story. Okay, and particularly in firewalls, you can uh, I mean, you can have no knowledge of practical, I mean, no knowledge of theory stuff, and there are people like that in the industry right now. I mean, they would not have a lot of theory knowledge on how the device actually works with its internal nitty-gritties. But yeah, I mean, like if you tell them, okay, like let's configure this access policy and like stuff, they would be able to do it, right? But again, that is not to say that they have any theoretical background of it. Particularly about this course, since we are chasing, I mean, this is not an outright firewall course, right? I mean, this is a score, right, wherein we are kind of expecting that people would be going for certifications and those kind of things. We also would need to have some theoretical background of stuff, right? And within regards to what Cisco has laid down in terms of uh, like like the layout, right? And our PDFs, by the way, are designed for that, and people have been clearing certifications, right? So in case you want to do that, you can certainly do that, and all of this will help you. Okay, that being said, let's begin with some theory introduction. By the way, Nick, I do not know you guys. Can I have a short introduction from your end, just so that I know, where is everybody placed, and maybe I can, keep that in mind when I'm discussing stuff. So I would know you. Okay, I think I'll call out names and then probably you can unmute yourself and a very short introduction, meaning your name and uh, what all the other courses have you attended at PyNet Labs and uh, what's your work profile in case you're working. All right, so I guess Anthony, if you can hear me.
Yeah.
Hi, Anthony.
Hi, my name is Anthony Frimpong. I've been in the network industry for 1 year, just 1 year. I'm very new to it, and I've been in the Wi-Fi space, and I was in the Python class, the one that just ended, and firewall is very new to me, so I just want to learn it and add it to my skills for the future. Yes, that's basically it. Thank you.
Great, Anthony. Yes, certainly. Yeah, certainly you would certainly make up a lot of good basis on your security stuff from this course. So best of luck, and
Thank you.
hoping this would be fruitful uh, to your purpose. Okay, Michael, I hope I'm pronouncing it correctly. Or
Hey,
Michelle.
yeah, it's Michelle.
Michelle. Yeah, sorry. Yeah,
Hey,
Michelle,
hi.
please go.
Hi, my name is Michelle. I'm a network engineer for a hospital, and I've been taking a few classes from PyNet Lab. And I just ended the Ansible class like on Wednesday, so I decided to take the firewall class just to, yeah, because I don't know much about firewall as well, so I'm just trying to strengthen my knowledge of the firewall aspect and an FTD as well.
All right, all right. So I think most people are. So is it like that, or most people are from the automation side, or something like that? But in a good sense, I mean, this is yeah. I mean, like in many ways, you'll see that uh, security course on that end is quite sorted. Okay, because you'll see much of it is kind of GUI. In fact, unlike other courses where you kind of have to learn a lot of commands. I mean, here of course you have those things, but it is something which is not recommended, right? In fact, GUI and next stuff is so this is going to be interesting, and with those background stuff that we'll be doing. Yeah, yes, Michelle. So again, best of luck to you as well. Hoping this will be fruitful to your purpose.
Thank
All
you.
right. Yeah. Sachin, can you hear me?
Yeah, hi.
Hi,
Hi,
Sachin.
Sohail. This is Sachin here from actually, I'm working in HCL as a network engineer. So basically, I worked in the firewalls, Palo Alto firewalls, switching and all.
Okay. All right. So have you worked with firewalls? What all firewalls have you worked with?
Only the Palo Alto.
All right. Yeah. So
Yeah.
Palo Alto, of course, is a very good firewall. And then you'll see very close resemblance. In fact, whatever firewall you kind of do, they always
Mhm.
have very similar resemblance in the working and the GUI of course changes and the interface of course changes, but you'll see they have very similar functioning. In fact, when you work with one firewall, it becomes very easy to work with other ones. Only
Mhm.
of course some specifics change, but otherwise they kind of work very similarly as you will see as well. All right, so your
Mhm.
best of luck, Sachin. uh,
Yeah. Thank you.
Rupesh.
Yes, sir. So, hi everyone. So, my name is Rupesh, and I have around 10 years of experience in network domain. I do have some doubts with the security. So, majorly, I have worked on a routing and switching part.
All
So,
right,
so my expectation is I have to clear my concept in the security as well. So, that's why.
all right, best of luck, Rupesh.
Mhm.
uh, I hope I'm pronouncing this clearly. Tyag, is, or how do you
Yeah,
pronounce it?
hi. Yeah, it's Tyag here. I'm from basically from Bangalore, work in IBM as a network operations engineer. I've got a 5 years of experience. I wanted to upgrade my skills in the security level. That's the reason I joined this course, and I wanted to take it forward on this. Yeah. So
Oh, okay. All right. Best of luck. Best of luck again. I
thank
hope
you.
this adds to your profile in a good way. Yasir. Yasir, can you hear me? All right, maybe he cannot, or maybe that uh, is unable to unmute or something. All right, so I have a fairly good understanding of what the audience is, and of course, like always, this is a mix of very different audience, right, with very various different levels. And any which ways, I will always be addressing stuff, assuming everybody is a fresher. Okay, so people who already know a bit of things. Uh, it's kind please treat it as a refresher maybe, and any which ways refreshers are always helpful, and for people of course who are new would certainly benefit from this thing. All right, so within this first lecture, okay, let's start off with this, and I guess there are some more people, maybe they'll join, or maybe I don't know, maybe they'll stick to the recorded sessions. You have some crowd always that kind of sticks with the recorded session sort of, right? uh, Possibly because of the timings and like stuff, right? So any which ways, let's start off with our uh, terminologies, right? There are some again these like I said, I mean, some of you possibly might know this, some of you would not. The entire point is, again, although it may seem trivial, like at some point in time, this is mainly so that you can tackle those basic questions, at least when you appear for escort examinations or even for other security interviews, and you are required to attend some written examinations or MCQs, right? So this is in regards with those things, and let's start off with some terminologies, okay, and some like theory background like for it. Okay, let's understand this. And yeah, okay, so basically what we're trying to understand is some terminologies. This is the first actual lecture, right? All right, so let's begin. Okay, so where does security come into picture, by the way, right? Security comes into picture because right now you have all your modern networks, right? Of course, as like most of you are working, right? And you of course work with all your modern networks. When I say modern networks, these are highly connected internet and whatnot, and these are at most times, like, these are very large complicated networks. And in fact, it's not only that, I mean, you have them interconnected with a wide variety of other networks, right? Maybe your own organization, or maybe like some other things, or maybe the internet or next stuff. This, as you of course know, we have a interconnected world, right? In fact, you kind of want everything to be connected to something else, and all of that is good. I mean, in terms of productivity, of course, this I mean, nothing can be more beneficial than this, right? It certainly helps where you have all of this connectivity, and it certainly helps with all of these things. But then what you have is a possibility of remote attacks, right? Because then somebody sitting somewhere in the other part of the world, because of this interconnectivity, can uh, pose a threat to you, right? They can attack you. Uh, they can harm your network. Sometimes they may steal something, right? So attacks, of course, can be where they uh, steal some information, right? Information, of course, being like a very crucial thing right now. Data is data, right? Data is super important, but it is not always stealing. Okay, please do understand, the attacks are not always about stealing stuff or getting unauthorized access. Sometimes it is, yeah, it could be unauthorized access as well, by the way. So nobody's harming anything, nobody's doing anything, it's just reconnaissance, right? I mean, somebody's there in your network, just sitting and watching all the data flow through, grabbing stuff, reading stuff. Could be, but again, it is kind of like stealing information. But apart from it, it could just be taking down some devices. Okay, so what do I mean? I mean, maybe let's say you have a very important router. I mean, literally a very important router that serves as the backbone of your networks and like stuff, right? And somebody is well aware of that, and what they want to do is they want to bring it down, possibly, right? They might want to bring it down, and yeah, I mean, like that's a very real possibility, right? People would simply want to bring down your network or your services, right? uh, yeah, I mean, like, that is what attacks are also possible. I mean, like, that is what also is a possibility, right? I mean, nobody wants to steal anything from you, but just so that your business is harmed, your customers are upset, Some people might just simply attack you, and that is also an end goal. So yeah, this is essentially what can happen, right? And this is where security comes into picture, by the way. So because you have these modern networks, right, and because you have this interconnectivity, and this interconnectivity just keeps on improving in terms of efficiency, and therefore also the possibility of remote attacks, right? And this is why you have network security, by the way, in picture. Yeah, by the way, also specifying uh, this industry what we're dealing with right now, because this is kind of a confusion point, right, for people. What we're dealing right now is with network security. Okay. By the way, there is also one more term which is cyber security, right? And people tend to get confused between these two. Cyber security is securing everything that is available in your domain. Okay, it's a larger perspective again, but it's too helter skelter actually, and it's all over the place essentially, because you're trying to secure everything. But that is what cyber security is. It's a larger umbrella. Network security is where we use firewalls, and we are more focused on devices. Okay, so this course of course is network security. We're focused on like devices like firewalls and stuff, and we are trying to secure our network, right? Network security, that therefore the name network security. We are trying to secure our network. Cyber security is where you try to secure your entire IT ecosystem. That's a very large thing in itself. It's like I said, it's kind of all over the place. Never has been my favorite because it is very vague, right? Because people that are supposed to I don't know, so they know bits and pieces of literally everything, but they are not masters of anything. Is kind of the problem that I have with that industry, by the way. At some point you would be securing your websites, which is kind of difficult because you're not a web developer, right? Sometime you'll be securing your phones. Again, you're not an operating system guy, but then again, at some point in time, you are securing some operating systems on your Linux systems and Unix systems, and the list goes on and on and on. So that's cybersecurity. That is not what we are dealing with. Okay, we are dealing with network security. Just specifying so that you know the industry that we are dealing with. Particularly this is for freshers, right? So so for people who are new to this industry, right? So if you were confused about network security and cyber security in like two different spaces, this is what it is, right? We are dealing with network security. We are securing networks, and that is generally done using firewalls and those kind of stuff. So it's a pretty sorted field. You have to be kind of a master of one thing, and I think this is advantageous in number of ways, rather than having bits and pieces of information here and there, and like something changes and there's a new patch. And so yeah, I mean, like for me, I mean, like cybersecurity was always kind of too vague. Anyway, that's just a personal opinion. Yours could be different. That's okay. All right. So yeah, given all of these things, okay, you have your network, and uh, we are aiming to make the network secure, right? Or like any which ways, like whenever you work in security, maybe even this or something else, uh, your focus is on something which is called as the CIA triad. Okay, your focus is always on something which is called as the CIA triad. Now, what does this stand for? So this stands for, and of course these things are basic things asked in interviews and like stuff and MCQs, and although it is of course pretty trivial, but yeah, it is nonetheless asked. So C stands here for confidentiality. Okay, this is confidentiality. The I stands for integrity, and the third is availability. Okay, so what is this all about? So what this is all about is see, confidentiality simply means that I mean, these are kind of our end goals, right? And so when you say you are in network security, so what's your end goal? Our end goal is to provide CIA, right, which is confidentiality, integrity, and availability. So what does this mean? Right? Confidentiality, of course, means that access should only be provided to uh, you know people who have uh, the right credentials and stuff, right? I mean, so there shouldn't be any unauthorized access. Okay, confidentiality is also so that people have confidential information, right? And only they are able to, view or access those resources. So confidentiality is all about access and authorized access, basically, right? So authorized access is something that should be there in your network. Okay? And there should never be a space where unauthorized people have, some kind of an access. And of course, that is not how things should be, right? So you should always have a confidential network, right? Meaning nobody else other than the required party should have access to stuff. Okay, that's one thing. Integrity, right? Integrity is about modification, right? So again, there shouldn't be any unauthorized access, or not in terms of access, basically like modification. So let's say somebody sending traffic from like destination A to destination B. No, unauthorized access should like be able to grab some data, modify it, and send it back again. Okay, that should never be possible, because this is how hacking happens, right? In most of your cases, there is somebody sitting in the middle who's sniffing up packets, then they modify it, and then they send it back, and you kind of have a hacked scenario. So something like that should never be happening. Your network should always have integrity. Okay, what that basically means is there shouldn't be any unauthorized modifications. So no unauthorized modifications. Okay, that shouldn't never be allowed. It should never be there. And finally, availability, right? So like I said, I mean, it's not always about people trying to grab your information, and people trying to steal some information. No. Okay, some attacks would simply be about disrupting your service. Okay, some networks, like some bad actors will simply enjoy putting you in misery, right? I mean, let's say for example, you're a search engine like Google. Okay, yeah, I mean, your competitors would certainly benefit if your search engine doesn't work, right? Because it is flooded with your requests endlessly, right? And there's an endless attack on you, right? And you cannot serve your genuine customer. Of course, you will start losing your customers, right? Nobody will come to your search engine if your search engine doesn't help, right? Of course, I mean, if it cannot serve you, you will see that people kind of start moving to some other platforms. So yeah, I mean, like that kind of helps. So um, availability simply means that you should always have uninterrupted access. You should always have uninterrupted access, and it should like flow correctly, right? I mean, it should always have an uninterrupted access, right? That is basically like what it is. And basically, whenever you see this CIA triad, it will always be shown as a triangle, because these three things are kind of, they go hand in hand. I mean, they should work together. So you have CIA, it's written something like this when you see it in textbooks and like stuff, right? So confidentiality on one side, integrity on the other side, and the availability on the other side, right? So this is the CIA triad, as it is called. Okay, cool. So that's basically the CIA triad. Again, something that you kind of need to know if you are in this industry. A very, very common question, that kind of people ask on these things. All right. So what else? So what are you here for, right? I mean, like when you are in the networking thing, there are certain things that you want to do, and it makes sense to define them in terms of some terminologies. Okay, so again, some more terminologies. All right, so what are these? Now, one important thing is for you to know is your assets. Okay, now what are assets? Assets are essentially anything of value to your organization. Okay, in fact, as a security engineer or as a security administrator or whosoever you are, your job is to protect these assets. Okay, now assets could be anything, by the way. Assets is anything of that of value to your organization. Now this could be okay, let me just write this down. So anything of value to your organization, right? So anything of value to your organization. So this essentially could be anything. I mean, it could be data, it could be, I mean, that's the most important part. Actually, information is the most crucial part. I mean, I don't know if you can imagine this. If somebody like it thinks that that is not the case. I'll give you an example. So for example, a bank, right? Banking details, account information is absolutely crucial. Tomorrow, if you hear, and again, some competitor may do that. So if you hack a bank and maybe tomorrow it's in the news, okay, that this bank got hacked, and you hear this information, right? I mean, some service got compromised, and you have leaked databases and stuff. And what do you think is going to happen? Like going to happen to their service? Yeah, people will not be trusting them anymore, right? With those services, right? So because they lost an asset, right? An asset got compromised. In fact, a very important one: usernames and passwords and databases. uh, Never ever should that be happening. So assets is anything that is of value. By the way, these could be devices, actual hardware devices, but then see, hardware devices can always be replaced. Okay, data once lost uh, cannot be replaced, right? So hardware in that sense can always be replaced. It can always be backed up. You can do so many things with it. Data, not so much. Data, hence, is absolutely crucial. But anyways, asset could be anything that is of value to your organization and therefore needs to be protected, right? So that's assets. Okay, what else? So you may have vulnerabilities. Okay, you may have vulnerabilities, or vulnerability in short, right? So what are these? So vulnerability is any weakness. Okay, any weakness, any weak link uh, in your chain of things. Okay, so maybe it's a software, maybe it's a hardware, maybe it is something like that, right? So vulnerabilities are weaknesses in your system, in your network, in your environment that can lead to attacks, right? So these are vulnerabilities. They are called as vulnerabilities. So whenever you hear the word vulnerabilities, they are basically speaking of some weaknesses. Okay, then there is something called as exploit. Okay, what is exploit? Exploit essentially is a method that somebody uses to exploit or take advantage of a vulnerability. Okay, so you have a vulnerability, which is a weakness, and then somebody uses some method to leverage the weakness. I mean, of course, in their favor. Okay, so they possibly want to leverage the weakness to their advantage, and that is what is called as an exploit. So there could be a number of exploits relating to a lot of stuff depending on what the weakness is. It could be a hardware thing, it could be a software thing, it could be a network thing, by the way. It could be some protocol that we use, and it may have some inherent vulnerabilities. Okay, and that is how this entire thing basically works. Okay, you may have threats, right? Now, what are threats? Threats are essentially potential danger. Okay, so the essential potential danger that is possible. Okay, given the vulnerabilities, given the exploits, okay, you have a potential danger to your environment. Okay, you have a potential danger to your environment, right? So you have vulnerabilities, which are weaknesses. You have exploits, which leverage those weaknesses, and together these things they form threat. These are the potential danger to your organization. Okay, so what are you supposed to do? What we would generally do is design some countermeasure. Okay, you will design or describe or declare or define some countermeasure. Now, what is a countermeasure? Countermeasure, of course, is some protection mechanism. Okay, some protection mechanism. Why are you doing this, right? So this mechanism is to reduce or mitigate. Okay, now please do understand, it is not always that you can entirely get rid of an entire problem. Okay, that may not be possible. Okay, that essentially may not be possible. You possibly may not be able to get rid of the entire problem as a whole. Okay, there might be only possible mechanisms where you reduce the possibility of a harm. Okay, uh, getting rid of the entire thing may not even be possible. Okay, so maybe so countermeasures are based on that. So it is a protection mechanism. Basically, you can reduce it in some other cases. Yeah, meaning you may be able to completely avoid it. Okay, so but yeah, these are some essential big things. Okay? These are some things that uh, you know. Kind of help you define the entire layout and like stuff. All right, so this is essentially some terminologies. Of course, there are many more which we'll discuss. We have been in the class for more than an hour. Let's take a short break, 10 minutes. Let's come back and discuss this further. All right, 10 minutes, guys. All right, so what we were discussing was so we kind of had an overview of uh, certain terminologies, right? Okay, let's take a little deep dive into those so that it makes much more sense. All right, so we did discuss vulnerability, right? And what that basically means is that you have some kind of a weakness, right? Some kind of a weakness in your systems, in your network, in various things. Okay, let's kind of discuss in a basic overview sense what can these be things, right? So basically, policy flaws. Okay, now see, it may not always be some actual uh, physical or even logical stuff, right? Some things like basic policies, okay, like the policy setup in your network, or the way you handle passwords, or the way you handle uh, security in your organization. I mean, again, this is I'm not saying that this is like even a actual flaw in the sense of a software or a hardware. Okay, so the policies that you make in your organization, you can have some policy flaws, and of course there could be other actual security policies that might have some kind of a glitch, some kind of a loophole in them, and yeah, certainly those can be some things. All right, so vulnerabilities can also be kind of those things where you have policy flaws. You might have some design errors within uh, you know like the making of things, like the make of things. So maybe you design your network, you design your system, and that itself has led to some weaknesses. Okay, it could be that there's a way to get around your network design. Okay, and yeah, I mean, like it creates like a blind spot in your network. It could be, there could be protocol weaknesses, right? So you can have you may use some protocols in your network, right, and they may have inherent weaknesses, or maybe it's not the protocol itself, but the way you use it, the way you implement it. Maybe the protocol has some recommended stuff that you are not basically using. Okay, so it may cause it to prove as a weakness, right? You can have those things. Maybe it is a software weakness, right? Again, many organizations use customized softwares for a lot of for their things, and maybe they have the way they are implemented, or maybe inherently, right, they are just flawed. They're just even with right now, you see vibe coding, right, as it is called, with AI and stuff, and you can code stuff by just putting in prompts, and people are happily making applications. It is going to lead, I mean, and it is leading to a lot of cyber security issues, right, wherein people with no knowledge whatsoever of software programming, they are just putting in some random prompts, and the AI does some half uh, hearted stuff, and then you have applications which seem fine, probably maybe at first glance, and they might be riddled with security issues, right? So because that's what it is happening with AI and stuff, right? So it is like currently the way things are being implemented, and wipe coding as it is getting popular for like weird reasons. I mean, that is what is going to happen, right? And that is what is happening right now. So you have those softwares with not much of security in them, not enough consideration given. You could have a lot of weaknesses, right, in the systems inherently, and these, of course, will prove to be a weakness. Sometimes it is just misconfiguration. In fact, most of the times, okay, I don't remember the exact number right now, but I just read I did read a report on this, and most of your security issues that were created, right, they were not because of some uh, random like stuff, okay, like not system level stuff. These were misconfigurations, okay, human factors, okay, like somebody misconfigured something somewhere, and that led to a whole huge issue. So misconfigurations, right? I mean, those can prove to be a weakness. Yeah, maybe you did not intend to configure it something like some way, but yeah, at the end of it, you have configured it. Maybe like it's an error. Maybe you missed out something, and that is now a misconfiguration, right? And of course, it can prove to be a weakness which can be leveraged, right? So it's a vulnerability now, and that is essentially how is this happening. You can have, apart from all of this, human factors, right? Essentially, however, whenever hacking and like those kind of things happen, sometimes apart from the technical like stuff, okay, like fine, maybe you have a very well defined technical environment which secures you and like all those things, but a lot of attack also happens because of social engineering, as it is called, right? Social engineering meaning uh, simply that hackers, they leverage, or the attackers would leverage human factors in their favor, right? Meaning somebody, let's say, calls your employee, and they say that maybe I'm the admin, and I need your password, right, for something, or maybe you got locked off your account, and or maybe something like that, right? And they just give out the password. Now, of course, there was no policy flaw, there was no design error, and none of that, right? I mean, it was just human factors. Somebody just got scared that they are receiving the call from an admin or maybe something like that, and they just gave out the password. So yeah, human factors, of course, also play a role. Now, again, all of these things can be prevented with better training, right? Meaning, as a rule, it can be imposed that no matter who calls you or whatever happens, you are never ever supposed to give out your password, right? And things like that. I mean, with better training, of course, you can prevent those things, but these things also play a very crucial role uh, in your network stuff, right? They can prove to be disastrous, by the way, right? So yeah, basically, those are some vulnerabilities. Now, uh, for you to be able to tackle this, as we kind of discussed, you have countermeasures, right? You have countermeasures which are essentially some sort of a mitigation, some sort of a reduction in your threats, right? That you possibly might want to do. Now, countermeasures, they can be administrative, okay, meaning they might be administrative rules, okay, just administrative rules, maybe better policies, maybe better password protection policies that nobody's supposed to keep. A lot of organizations, people play very leniently about the passwords. They sometimes have sticky tags and just paste it on their laptops, right, for the password, because the password is so complex, or maybe something like that. So some administrative mechanisms, some better administrative decision making, better policies can prevent attacks too, right? But this could be technical, right? Of course, it also has to be technical uh, solutions. I mean, for example, let's say we deploy a better firewall with better policies. Like, that's a technical solution. It has nothing to do with the policies of your organization, right? This is just us hardening the network in terms of actual technical solutions. So yeah, you can of course do those things, and of course that is what we are here for. Uh, you could also have physical protection, okay, like of course you cannot just leave your devices out in the open, right? Meaning, of course, there is always a secured room for your devices, for your for your like servers, and all your important devices, right? Physical access is also crucial, right? Somebody may just be in the same location, right? Meaning maybe some rogue employee, or maybe somebody who has access to your physical network will of course use that leverage, right? Of course, they can use this leverage, and of course they can harm the device, or maybe something to do with the device, right? So physical countermeasures can also be taken, and that is what also you can do. By the way, when you talk about countermeasures, they can always be preventive. Okay, and as you can imagine, preventive is to imagine these countermeasures before things happen. Okay, like as a thing to mitigate it before like the actual hack happens. You could also have detective, right? Meaning whenever things are happening, okay, you might want to detect it, and that is also countermeasure, right? I mean, let's say a hack is happening right now and your systems detect it. There are of course systems, even firewalls can do that. They can outright detect and notify you if they feel, and the word is feel actually, because they look into trends. They can look into the traffic and they can determine if maybe there's an attack which is ongoing, right? And that's a detective thing, meaning it's not a preventive thing. You are not now doing a preventive task. The attack is actually happening, and for the duration of the attack, maybe you want to figure out something to prevent damage to your network. And of course, after all of that, you also have corrective mechanisms, right? So fine, I mean, the attack did happen, right? And now you want to look for corrective actions, okay, to uh, correct things, maybe to plug loopholes, right? And those kinds of things. So maybe the attack has already happened, but now you want to minimize the damage, right, that is caused. You want to bring your systems online back up again, maybe, or things like that, right? And those are some corrective actions. So yeah, whenever you talk about countermeasures, they can be preventive, they can be detective, and they can be corrective in nature, right? They can also be all of these. Okay, so all in all, with all of these things, what are we kind of doing? Okay, what we are kind of doing is uh, we are managing the risk. Okay, what we are doing is we are managing the risk. Now, how would you define risk in a very technical sense? Okay, like in terms of network security, you know what risk is, like in terms of English language. No, that is not what I mean. So risk, uh, what does it mean in terms of a network security language? So in terms of network security, or risk is all the threats, okay, all the threats uh, put together times your vulnerabilities, okay, times the impact that it causes. Okay, so threats times vulnerabilities times impact is what is the risk. Okay, that is the entire risk to your environment, right? So as we kind of discussed earlier, threat is essentially the method, right? The method that you leverage, that you use to leverage the vulnerability. Okay, so threat is the method exploiting a vulnerability, right? So it's the method. uh, Vulnerability, right? Vulnerability of course is the weakness. Okay, that is basically uh, like the weakness. The impact, okay, the impact is the resulting damage. Okay, like what is the resulting damage that is caused because of all of this? Okay, that is referred to as the impact. But this, all in all, okay, all of these form your total risk. Okay, so risk to your entire network or your system is basically threats times the vulnerabilities times the impact that it causes, right? Which is nothing but the total resulting damage. Okay, so yeah, okay, fine. So that's the risk that is involved, correct? That is the risk which is involved in the network. Uh, then there is of course risk management. Okay, there is of course risk management. Now, what do you mean by risk management? See, see, it is not always that you want to see the network. So, for example, everything has risk, right? Everything has a certain amount of risk in it. Nothing is 100% secure, right? Everything would. I mean, if you just like read about it a lot, and if you drill down on it, you will see that everything has vulnerabilities. Everything, literally everything, has vulnerabilities. Do we go about patching everything? Possibly not, right? I mean, that is not how things really happen. Okay, so this is about risk management, right? You want to manage the risk, and so what are the ways in you can manage the risk? See, one is basically you can accept it. Okay, you can accept the risk. Okay, now what does this mean? So see, whenever you try to avoid a risk, right? So let's say there is a given risk for you, right? And you want to avoid that risk, correct? There is always a cost attached to it, meaning in terms of some device that you want to get, some firewall, some manners that you need to put in, or something, some policies, and the cost can be very small, the cost can be very large, okay, depending on what your risk is and how you are trying to avert it. There could be a cost to it, but there is always a cost, right? There is always a cost, and in terms of monetary cost, in terms of human hours, right, in terms of knowledge cost, these things are always there. There might be costs in terms of complexities that you add to your network. Okay, maybe just as an example, okay, like there is two-factor authentication. Now there is one more thing to do. Your device is maybe for people to log in. Now you have to have your phone. Okay, what if the phone is not there then, or maybe like something happened to the phone itself? Yeah, people would not be allowed to log in then, right? So everything has like a give and take, a pro and a con, right? So things like that, right? Everything has a cost, however. So risk acceptance is where you accept the risk. Okay, like you just, I mean, yeah, this literally means that you are okay with the risk being there. Okay, now you would say like, why would anybody do this? Yeah, of course you can do this. Maybe the risk is very small. Okay, risk is pretty small, and I mean, it may not have a lot of impact any which ways. Okay, this is a very small risk. I mean, it's not gonna do anything critical to your network, and the cost of it, however, right, is very large. Okay, meaning this is particularly so when do you choose to accept the risk? So this is where the avoidance cost. Okay, the cost of avoidance is basically larger. Okay, the avoidance cost is larger than the risk itself. Okay, meaning the total avoidance cost is larger than the risk itself. Okay, so that's like a thing. Okay, so that is something that you might want to avoid altogether, because if the cost is like too large and the risk itself is too small, yeah, you can choose to like ignore it and you can accept, yeah, okay, fine, like that's the risk that we have in the network, fine. Okay, that's what it is. uh, Sometimes you may want to avoid the risk, right? So sometimes, of course, certainly what you want to do is you might want to avoid the risk, and this is always the most expensive, right? Because you are trying to get rid of the risk, right? It is always the most expensive, and yeah, what you're basically trying to do is you are trying to avoid the risk, as the name suggests, right? You're trying to limit your exposure to the risk, or maybe simply get rid of it entirely. Okay, so yeah, it is, but then the costs are always more expensive, right? Because you will have to get a new device probably, or maybe some specific policies or some stringent complexity or something like that, right? And this always involves a lot of cost. Okay, sometimes you may want to simply have risk limitation. Okay, so this is like a give and take. Limitation, as the name suggests, I mean, you do not outright avoid the risk, neither do you accept the risk as a whole. Okay, in fact, as the name suggests, right, you want to limit the risk. You want to limit the risk, meaning you're not getting rid of it entirely. In a way, you could say that this is like a combination of acceptance plus avoidance. Okay, so you're not getting rid of it entirely, neither you are uh, avoiding it completely, or neither you're accepting it completely, right? So somewhere in the middle, you're trying to limit the impact of it, right? And that is what is risk limitation. In certain cases still, Okay, in certain cases still, what you will do is you will transfer the risk. Okay, now what does this mean? Okay, so in such cases, what you can do is you can transfer the risk to a third party. Okay, you can transfer the risk to a third party. Okay, now what does this mean? Okay, so for example, one simple example I can give you is maybe you want to outsource the risk mitigation to an outside firm. Okay, you are essentially transferring the risk to that third party, and they should be able to take care of it. If for some reason they cannot, of course they will be penalized, right? I mean, they'll have to bear the cost of not being able to secure you, correct? So yes, I mean, that's essentially you're transferring the risk. Now, one more example I can give you is insurance, right? So you are trying to mitigate the risk, right? Or you are doing all that is possible in your case, but then you get an insurance. Okay, meaning if you were hacked or maybe there was some attack or something like that, and maybe some insurance company would then like have an insurance to you. Okay, so you're kind of transferring the risk again to this insurance company. Okay, because you would not be uh, bearing the brunt of the attack, right? I mean, in terms of cost, there would be some third party organization that you're transferring the cost to. Okay, so that is essentially called as risk transfer. This is also something that happens, although I mean, of course, that depends on what you're trying to secure, right? If you are attacked and if you lose your database and if you lose your service, I mean, and yeah, I mean, like you can, in terms of monetary cost, yeah, you can transfer the risk, but then uh, the loss of reputation and those things, of course, are yours, right? You cannot. How would you transfer that to somebody else? Of course, you cannot do that. But yeah, this is basically like one of those things. Okay, so what else? You have, I mean, of course, to avoid all of this, like in the first place, in even with risk management and like those things, one thing that you need to be sure of is that you have a vulnerability assessment, right? So we have been talking about like vulnerabilities, but then how would you know? Okay, how would you know if your network has vulnerability, right? Of course, you would not know unless there's an assessment, right? So you'll have to have a vulnerability assessment to ensure or to understand, okay, to understand what are the vulnerabilities in your organization or in your environment, right? So, for example, there could be defects, right? Now, when I say defects, the defects could be in your softwares, correct? There could be defects in your hardware, right? Your hardware has some issues, right? And some like attacks will in fact use these paired together, meaning there could be paired exploits, right? Meaning there are certain exploits which kind of leverage both of these things, right? Software plus hardware put together, meaning like a flawed software plus a flawed hardware, and they can of course be used to do a lot of damage, right? And this can be done. Uh, Whether or not also like this is one thing, like software hardware defects is like one thing. A lot of damage can also be done through something called as device discovery, right? Meaning somebody just scanning your network, right? And kind of assuming and imagining what is a network like, right? So when they do so, they are able to identify the devices, and there is, I mean, this is not a very complicated thing, by the way. Something like just ping or a scan that does a ping scan can identify a lot of devices, and your network, how it works and what are the devices and what are the IP addresses. And you of course may want to somehow prevent this, okay, so that nobody is able to do some reconnaissance on your network in such a way, of course, that it harms your devices, right, and things like that. Now, beyond this, what you would have is service, right? So you of course in your network run a lot of services, right? You run a lot of services in your network, and they have their own vulnerabilities, right? Meaning you possibly of course have things running on the TCP platform, right, on the UDP thing, right, as a bunch of protocols. Maybe you run some services, or maybe you run some web services or some particular services that are available from your end, right? And these might have defects in themselves, or maybe they have exploits or vulnerabilities that can be leveraged, correct? So yes, I mean that is something that you can do. Okay, you can check those things out. What are the things that you are using? Maybe you can avoid using things that you're not using altogether, meaning there are of course TCP and UDP, there are a lot of ports which are open, and you can choose to simply block them, right, if they are not in use, and that they would not be like in use, and like those things, right? So yeah, I mean, like those things are something that you can like do. You can so when you are uh, when you are basically like doing an assessment, you can also, like I said earlier as well, you can do a scan of your network, right? And you can also scan things for configuration issues, right? Or maybe missed patches, or like those things, right? You can check for configuration issues. Okay, again, there are many softwares that will help you do these things. They check for configuration issues, and maybe weak configurations even, or things like that. And maybe if you missed out on patches, right? So patches, you know what patches are, right? Patches are basically, let's say you run your operating system, you run some hardware, some device, and it has some software, right? And like I said, I mean, rarely is anything without any uh, without any loopholes, right? There is always something that can be leveraged, and there may be some bug in the software or something like that, and they have to be regularly patched, right? Meaning somebody finds out that there's a bug, they kind of highlight it, and the organization, I mean, like the manufacturing organization will come up with a solution, right? So they'll give you a patch basically to patch the vulnerability, and of course these cannot be missed, right? But it can happen that you missed maybe some patches, and of course you can like fix those things. There could be uh, some dangerous services which are running, right? Dangerous, and like uh, I mean, of course these are services that are known to be vulnerable. Okay, maybe like in your network, and they are open, and of course the hackers will take advantage of this, right? Of course they would. And yeah, like this is essentially uh, like one of those things that you might want to look into, right? So these are like some things that may help you figure out your network. Again, the entire team has to do this. It's not only you, and maybe it is like an inter security department thing. Okay, I mean, we as network engineers or security engineers, and you'll have to pair up with the cybersecurity team as well, and we'll have to come up with solutions to better protect the network, right? That could be like a thing. So yeah, like those are some like some things. Okay, for example, okay, let's discuss this through. So you know, of course, that there is I mean, we of course use the TCP UDP kind of protocols to do our stuff, right? And the TCP IP suite kind of details out those things, right? I mean, how this entire thing basically happens, right? Within TCP IP suite, right? If you kind of look into it, you will see that of course it uses the IP protocol, right? It uses the TCP network, right? And it uses the UDP stuff, and all those things with the ICMP. So this entire thing kind of makes up your TCP/IP suite works, right? I mean, the IP protocols, IPv4, IPv6 with your IP address stuff going on. You have the TCP at layer 4, and the UDP, right? And ICMPs, all those ping kind of stuff, right? All the reporting business that happens on the network. Now, all of this is of course running, and this is for your advantage, and this is how the network usually operates. But there are vulnerabilities as always, right? There, like I said, I mean, there is hardly anything that does not have vulnerabilities. Okay, so for example, uh, with these things running, okay, you can have something which is called as the MITM attack. Okay, man in the middle attack. So man in the middle, so this is basically referred to as the man in the middle attack. Now, man in the middle attack basically is what the name implies, right? So this is essentially what the name implies, and basically what you have is, let's say you have a device, let's say A. Okay, you have some device A, and it is willing to, let's say, communicate with this device B. Okay, pretty straightforward stuff happening here. But what can happen is, there is possibly a hacker or some like a malicious user sitting at like the other end, and what they essentially do is they act like the man in the middle. Okay, so maybe like they have a device C, and what they're doing is they are redirecting traffic, okay, to them. Okay, now it may be that device C, okay, is it makes it seem to device A as if this was device B. Okay, so when A is trying to communicate with B, it is rather communicating with device C. Okay, and because it is making it seem, now there could be number of ways it can do this. Maybe it is spoofing the IP addresses. Okay, maybe it is spoofing the MAC addresses, or maybe like things like that, right? And on the other side, maybe this device A, device C poses as device A to device B, and they unintentionally send the communication through device C. Now maybe device C isn't really doing anything specific. Okay, maybe it is just sniffing up the packets. Maybe it is reading stuff, right? Again, but that's an attack, right? I mean, nobody should be able to read your information. And in worst case, I mean, of course, they can modify stuff and they can send it back and forth, and I mean, like it can be a problematic thing, of course, as you can imagine. So man in the middle attack generally is about interception. Okay, somebody is trying to intercept your communication, like posing as a genuine device. Okay, so these are basically man in the middle attacks, and they kind of like sniff up packets from like in the middle. Similar to that, what you can have is a session hijack. Okay, so man in the middle attack is one thing. There could be a session hijack. Session hijack is essentially, so right, that when two devices kind of communicate, okay, again, maybe like let's say there is a device A and maybe there's a device B, and that when you have a communication going on, let's say using TCP, it essentially forms a session, right, between those two devices, and that is how the communication flows through. Now, it may be so that somebody sitting in the middle hijacks this session, and there are numerous ways, by the way, like somebody can do this using some third-party softwares and tools, and they could uh, essentially hijack the session. Okay, so what that essentially would mean is it would intercept the session, and then it would again maybe pose as device A and like continue the rest of the conversation with device B. All this time, device B assuming that it is communicating with device A, which is not the case anymore, right? So this could, of course, be a problematic thing, and it is leveraging again the way TCP UDP works. Okay, somebody with very good knowledge of how TCP UDP works, and with the right softwares and third-party applications can easily do these things, right? It is a matter of just point and picking stuff and making this work. So session hijack is gaining access to a session, of course, unrightfully, and that is also something that happens. Okay, in the real world, that is also a problem. There could be some other things, right, as we kind of have discussed. So there could be IP spoofing. Okay, there could be IP spoofing where like something like a man in the middle attack, or like an attacker, okay, can spoof the source addresses. Okay, they can so the attacker here, okay, the attacker spoofs the source address. Okay, so what does that mean? So I mean, they can pose, right? They can pose themselves as a different source, right? And these are kind of things that are done for a number of reasons, right? Maybe you want to launch an attack from somewhere, and of course you cannot pose yourself as yourself, and you can pose yourself as somebody else, right? You can spoof your MAC addresses, you can spoof your IP addresses. Spoofing essentially means using a fake, right, a fake IP address, a fake MAC address, and doing those things. Okay, so with MITM, with session hijack, with IP spoofing, you are basically impersonating something, okay, that you are not, and this is generally to intercept communication, right? But this is not all. There could be other things. Okay, for example, like I have been saying, okay, from the start of this lecture, it is not always that you want to intercept stuff. Okay, so what do I mean by that? So there is something which is called as the denial of service attacks, and these are fairly common. Okay, so not in all cases that I want to intercept something and maybe I want to grab some information or like things like that. There could be something called as denial of service attacks. Okay, now what does that mean? What this essentially means is, let's say you have a very important server. Okay, you have a very important server, and it serves, of course, it's a server, it is serving something. Now let's say there is some attacker, okay, and we'll just call this device A. Okay, and this device A is the attacker, right? So there is like somebody, like a malicious user sitting and operating this device, and what they would do is they will flood, okay, they will flood my server with thousands of unnecessary requests. Okay, they will flood my server with unnecessary requests. Okay, like all, maybe it could be simple things like ping. Okay, but they are large pings. As you can imagine, when my server receives pings, I mean, of course, it has to respond back, right? Imagine I'm receiving millions of pings, and that to large packets and like those things. Of course, you can change the packet sizes, right, for ping and like those things. And you can imagine what will happen, right? I mean, my server essentially would go down, right, because it is no longer able to serve the actual genuine uh, uh, requests, right? It is flooded with these unnecessary requests, and my server is kind of going down, right? It is unable to keep up with the requests that are coming in. So essentially doing something as simple as flooding with ping, okay, can bring down your server, by the way, right? It's a very simple thing, by the way, and like hackers have been leveraging this, by the way, like in like for such a long time. Okay, so you're basically flooding the resources of your victim, and so that it is unable to serve anything that is of crucial critical importance, right? So that is essentially like what is called as DOS attack. Now with the current times, however, this has in fact even evolved. Okay, the DOS attack has kind of evolved into something called as a DDoS attack. Okay, now you have something called as a DDoS attack. So what happens in a DDoS attack? Now this, so basically DDoS is something which is called as distributed denial of service. Okay, so this is something which is called as distributed denial of service, and essentially what this means is that you have basically, let's say again, some server, okay, which is of course trying to like do its business, its job, right? And there is some attacker, okay, sitting on the other side. Let's call this device A, and so this guy is the hacker, let's say, right? Some sitting on some other side. This time, however, they will not be using their own devices, right? Because of course, when you do that, you're kind of exposing yourself to the world, right? Because I mean, of course, whenever you attack, and like people will come after you, right, through investigations and whatnot. So in this case, what you do is, in distributed DOS attack, what you do is you first infect some bots, some zombies, okay, as they are called. So these are actually also victims, okay. They will be launching the attack for you, okay, meaning first what you do is you infect these bots or zombies, right? Let's call them DEF. Okay, so these DEF devices are zombies, okay, or bots, okay, and you infect them and you install a trigger point and you install code in them such that on the trigger date or the trigger point, what happens is they go ahead and they launch an attack on the victim. Of course, now please do understand that these DEF devices are also victims. Okay? They are not part of the attack. I mean, they are, but not through consent. Okay, they might not even know that they are infected. Okay, and they launch an attack on the server. Now, again, if the server even kind of knows these devices and they get back to them, it's not going to help, right? Because they themselves are victims. These devices are kind of infected, right? The DEF devices are kind of infected, and this is basically like what is happening. So you, of course, now have leveraged this attack into something much more monstrous and kind of untraceable, right? Because now the device A, the attacker, is kind of not known, right? They are not known. They are somebody sitting on the backside of things. Okay. So, but yeah, this is distributed, or the DDoS attack, as it is called. And again, it's the same thing. I mean, it's flooding of resources is what you're trying to do. Okay, you're trying to flood the resources, and yeah, I mean, but however, the attack actually is launched. Okay, the attack is kind of launched from botnets, as they are called, or should I say, infected botnets. Okay, they are like infected botnets across the internet. Right, so this is also one kind of an attack, right? This is essentially like what that is. Okay, so yeah, interesting stuff. I mean, of course, we don't really need to go like into too depth, but yeah, these are some terms and like stuff that you have to kind of be aware of. Also, that we are not really interested in how to perform these things. Okay, this is not a hacking class, right? I mean, this is not what it is. These terms, these terminologies, we are kind of we want to understand them because we will encounter them regularly in our industry, right, in our domain. So we shouldn't be unaware of them, and that's the entire point, right? That's really all that there is to this. Okay, what else? You might also hear the word attack surface. Okay, sometimes. Okay, you'll also like keep hearing the word attack surface. So attack surface essentially is so it's basically uh, it's a total sum of all the vulnerabilities, right? Meaning, so what's the attack surface? In very simple language, this is the total sum, okay, of all the vulnerabilities, meaning all the weaknesses, right? Okay, all the vulnerabilities that are available to some attacker or some hacker, right? And when I say vulnerabilities again, these could be a lot of things. In a way, we kind of have discussed this in some other manner, but since yeah, attack surface is one specific word. So again, so when I say like what is the attack surface that is available to a hacker, like for my organization, again, it could be all those things that we have discussed, right? It could be the network, right? It could be your network. It could be, and when I say network, right? Okay, let's pin this down like specifically. So what all could be my vulnerabilities, right? So certain ports. Okay, again, physical and non-physical, right? Meaning like the protocol ports. Okay, those could be things. The actual protocols themselves, right? Meaning probably they are working or the way that they are implemented. Okay, because so for example, I know that routing protocols, for example, generally when we learn about them, we don't really implement protection over them, right? You just deploy EIGRP, for example, like EIGRP. Nobody usually talks about how to secure them, but in all protocols there is a mechanism to secure, through like you only pair up with some authorized neighbor, right? That's always there, but how many people do it? So yeah, I mean, like those things, right? So ports, protocols, you may have different channels which are open. Even in terms of wireless and stuff, you'll have to be aware of all the radio frequencies that are available. What are the devices that you're using, right? There could be an n number of devices, right? Security devices, I mean, like network devices, security devices, and what are their vulnerabilities, right? What are the network applications that you're using in your network, right? And do they leave some back doors open? Okay, because these are network applications, and that is what they do, right? They allow network connectivity. So maybe they are leaving some back doors open, right? Possibly you may have heard of mobile applications and some games and like stuff, because these now offer online connectivity. Okay, and they pose a huge risk, right? Sometimes because these are games, and yeah, I mean, like they may leave some back doors open, right? So that is on the network part. Possibly if you're using some kind of a software, right? And so what are the functions of this code that is available outside the network? Okay, meaning, yeah, you're using the software, which is fine, but is there any part of it which somebody from outside can leverage it through some vulnerability or something like that? Okay, meaning like any function of the code, okay, any function of the code available outside the network. Okay, and whether somebody can actually use this as like a leverage mechanism, is that a possibility? Is there a possibility like to do this? In case, yeah, I mean, then you have to kind of like figure this out, right? Yet still, and we have kind of discussed this before as well, you you have to be worried about the physical part of it as well. Okay, not everything is technical. What if the attacker is in the same location as your resources? Okay, maybe, like I said, I mean, it could be that this person is a rogue employee, right? I mean, or a like disgruntled employee. Okay, something untoward happened to them in the organization, and now they are willing to like take it out on the organization. Yeah, could be, right? Many a times the attack is not even from outside. It is in fact from within uh, your network, right? Within your network, within your resources, within your organization. So yeah, fairly common stuff, right? So in this case, right, the attacker is literally in the same location, right? And that is why it is also always important to physically uh, keep your devices and your servers and your information under physical lock and key. Okay, meaning like nobody other than the people required should have access to those crucial resources physically, I'm saying. Okay, like literally through cards and like all of those, and you can of course do those things in those rooms. Of course, nobody else should be allowed other than the absolute required personnel, right? So attacker of course could be, or maybe that they have access or they can gain access to the location, right? Attacker is in the same location, it could be, okay, as your resources. And yeah, finally, of course, like we have been discussing, right? Whenever you discuss the attack surface or the vulnerabilities, you also always have to talk about the human factor, right? So like I said, I mean, somebody can simply leverage social engineering, right? Maybe they act as a friend, or maybe uh, something like that. Somebody may, or maybe they leverage fear, right? Maybe they'll just call you, maybe it's a small organization and somebody just calls you up and says, I'm the director of the organization, and I need your password, or something like that, and I need it right now, right? And something like that, or maybe like it's an urgency and my account is kind of blocked, I need your account, and whatnot. I mean, so yeah, they're leveraging your fear, they're leveraging your insecurities, right, to leverage things again. no amount of technology is going to prevent this from happening, right? If the person just hands out the password to somebody else, like what good is your technology any which ways in such cases? Of course, not in the slightest. So yeah, these things kind of like happen, right? I mean, social engineering is a very big part of it, right? Without any use of technology, any technical intervention, I can I can bring down a network, right? If I want to, just using some social engineering stuff, right? So that's one of the things that you can like somebody might be be able to take advantage of. Uh, okay, what else? What else in terms of terminologies? Sometimes you may also hear the word attack vector. Again, these are kind of similar stuff that will be revolving around again and again. But I just want you to know these words in case you come across these words in our industry, right? So there's something called as the attack vector. So what is attack vector? Attack vector is the path taken. Okay, it is the path taken by the attacker, the actual path taken by the attacker to do some damage or maybe gain access or something like that. Okay, so that essentially is referred to as the attack vector. Now there are a number of ways it can do this, right? And we have kind of discussed this uh, like through all these things, but we'll take it like in a more direct approach. See, one of the things they can do is always do some reconnaissance, right? And there will always be some reconnaissance before the actual attack. Okay, meaning somebody will. So what's a reconnaissance, right? Reconnaissance is basically like gathering information. Okay, they basically try to gather information, and we kind of have discussed this somewhere on the top. So basically they can like scan your network, right? They can discover devices, what are the devices that you're using, right? All these things that we kind of discussed earlier, right? So you basically can scan the network, you can you can do a device discovery, right? What are the services that you're using, all of these, what are the softwares you're using, what is the hardware that you have, right? Because see, unless I know this, I would not be able to launch an attack, right? Like what do I launch an attack on if I do not know your capacities, if I do not know your capabilities? Yeah, I mean, like how do you actually execute an attack, right? Because this is what attack vector is, right? The part taken by the attacker to actually execute the attack, right? To execute attack. This is what it actually means. So yeah, I mean, reconnaissance, right, is about gathering information, right? And when I say gathering information, it is on various grounds, right? What are the devices that you're using? What are the ports? What are the services? Okay, what are the services? And like a number of things, right? All of this, like I said, will help me understand how vulnerable your network is, or maybe your asset is, if it's not the network only, right? And it will help me help the attacker understand, like these are the things, and then we can plan the attack, right? It's like that. So yeah, this is basically what they'll try to do. They will also try to then exploit the known vulnerabilities. So like I said, I mean, why is the reconnaissance happening in the first place, right? So that they would know, okay, that they would know that these are the vulnerabilities that you have. For example, just say, okay, maybe in the reconnaissance they kind of understood that you are using a certain kind of operating system, maybe a particular distribution for Linux, like something. Okay, like let's just say Ubuntu, okay, like for example. Now, if the hacker understands that you are using this operating system and possibly they're well aware of certain like vulnerabilities in it, yeah, they can possibly launch an attack based on those vulnerabilities, right? So the reconnaissance, of course, is happening for that, right? For that reason, in fact, maybe you use like let's say like this is one thing. Maybe like you use some kind of a phone, okay, like in your network, that there are some kind of phones with certain operating systems, and maybe like let's say some Android version. And yeah, like now like this attacker would know that these are the vulnerabilities that this network would have, and they can attack accordingly, right? So that's one thing. Similarly, let's say if you are running some websites, okay, you possibly, I don't know if you've heard this term. So there is something called as SQL injection. Okay, now SQL injection. So basically, SQL is structured query language, right? And it's used for databases, right? It's used for databases. So SQL, of course, has many flavors, by the way, MySQL and Oracle SQL and whatnot SQL, right? SQL is basically like a standardized language for databases, right? So in organizations where you have websites and like stuff, and you want to pull out information, they use SQL. SQL is like it's kind of a programming language sort of a thing, as you can imagine. Okay, if you do not know about it, if you know about it, it's like a whole different language, right? Which simply helps you, uh, do some crude stuff, right, with your database, meaning the creation, updation, deletion, update of your database, right? So one simple example is where you have a website, right, and maybe like people log into the website. Now, of course, for that to happen, of course, you would have some database with usernames and passwords, right? And SQL, of course, like when you hit that login button in the background, of course, it is running some SQL queries, okay, to check whether the username and like stuff is correct or not. Maybe, okay, like that's one of the things that can happen. SQL is known to have some bugs, okay, kind of like if you were to call them bugs, there are some like bugs in it, okay. Now you can exploit those things, and you can leverage those, and the SQL will simply pop out all the database information just like that. Okay, like some simple mistakes that you do, like willingly. I mean, of course, not that we are not doing it like unwillingly. Like let's say you like it is known. I mean, like SQL is known to like, unless you actually code it properly and like fix those things, uh, SQL can lead to a lot of dangerous issues. Okay, it can expose your entire database with simple manipulation of queries. Okay, so this is called as SQL injection. Somebody can simply modify, like the query which is sent to your database in the background. And by the way, this can easily be done in your address bar in your browser, right? You can simply extract. You can, I mean, like copy paste the query that is going through. You can like make some minor changes, and of course, it will just spew out all the database. In fact, the entire database of usernames and passwords, unless of course it is done the correct way. So this is a known vulnerability, right? SQL injection is something that they can kind of leverage, right? So yeah, basically SQL injection is like manipulating SQL bugs, kind of, okay, if you want to call that, okay, will result in application giving information. Now, of course, these things are well known, by the way. Again, and usually coders and developers will go around and like they'll fix those things. But let's say, I don't know, maybe like for the sake of cheap cost or something, or maybe like I said, right now it's AI, and like people are simply coding stuff with AI, vibe coding as it is called, and they do not know head tail of what the code is doing, right? And yeah, it can result to huge flaws in your network, and I mean, of course, people with the right knowledge will of course take advantage of it, right? So yeah, this is essentially one of those things that can happen in your network. You might have also heard of the term phishing. Okay, now phishing essentially is attacker sending in spam messages. Okay, so the attacker sending spam messages again. So this is not a so they would basically be sending you some spam messages, okay, some emails, or sometimes and of course, like in most cases, they will be impersonating somebody else, right? Meaning they'll act like your, I don't know, maybe company CEO, maybe your manager, and maybe there is a link to you reset your password, and by the way, like it, I mean, of course, it does not do that. It simply like gives away your password to the attacker or something like that, right? Something in like numerous ways that it can do it. So phishing is basically attacker sending in some spam, like emails or messages in some way and impersonating somebody else and getting information from you. Now, this could also take some serious forms. By the way, like this is not, I mean, like phishing is like a very straightforward mechanism of doing it, but then there could be malwares, right? There could be some malware. So malware is essentially uh, malicious software, right? This is the entire umbrella, by the way, uh, of the entire malicious software system, right? So malware is this huge umbrella under which the entire malicious software uh, kind of resides, right? So what do I mean? I mean malicious software. When I say this could be anything, right? For example, it could be viruses, right? It could be Trojans, right? It could be rootkits. Okay, we'll discuss this possibly in the next class tomorrow or something like that. A little more on these things. Okay, but yeah, I mean like this is essentially like what this is. Virus is essentially, or we can just discuss it right now. Virus is essentially like is code that will cause some harm. Okay, like maybe like it some does some damage to your system. Okay, so when you run them, possibly I don't know, maybe like it may attach to itself to a file. It kind of replicates as well, and it will flood your entire file system with it. Probably again, there could be different. I mean, there's no one way in which it will work. Of course, different viruses behave differently, and there are like tons of viruses out there. Trojan is it is more of a I mean, of course, the name that it gets is because of the Trojan horse, right? I mean, you possibly have heard of the story, right? The Trojan horse, where you know they kind of give this like the horse statue, okay, to their army. So basically, like two kings are at war, right? And like one king wants to enter their fortress, and which, by the way, they are unable to do, right? So basically, like this army of like these fighters, they are trying to get into their like fort, okay, and then they basically are unable to get inside, by the way. So essentially they kind of they plan a deceiving plan where they have this horse statue, okay, this horse statue, they kind of build it up, and they kind of give this as a like a gift to this other kingdom, because they are not able to of course get inside straight away, right, like through fighting and like stuff. Now when this horse comes inside of the fort, okay, uh, so there are like there are soldiers sitting inside, right, which they come out and they wreak havoc on the kingdom, right, through the inside. So that is where the Trojan word kind of comes in, and Trojan is like a software which kind of impersonates into doing something else. Okay, maybe like maybe they tell you like there are some kind of a different software, and you download it, and they claim to be something different, but in the background it is doing something else. Okay, meaning it maybe, I don't know, maybe it tells you that it is some kind of a app that I don't know, maybe syncs something to the online stuff or something like that, but that is what it just says. Okay, and that is what seems to you, but in the background it is like a back door. Okay, like the Trojan actually acts like a back door. Here the intent is not like the virus is kind of a self-replicating thing, which kind of populates your entire hardware resources, and thus is intended to do some damage, right? Maybe like delete files or like something like that. Trojan is unlike that. It kind of impersonates some other software, and then it kind of comes into your device, and then it maybe it is just listening to data or like something like that. It's kind of it seems like a gift to you, but it is not, right? And there could be some other things like rootkits, okay, which are very very sophisticated stuff. They are down at the operating system level, and they are essentially, rootkits are kind of like very hard to get rid of unless you format the entire operating system and whatnot. So then, so yeah, I mean, like malicious software could be like a lot of these things, right? Viruses, it could be Trojans, it could be rootkits, it could be something called as spywares, right? Spywares, again, as the name suggests, is spying on you, right? Again, the intention here is not to harm your system. In fact, you would not even know that these things exist because they're not doing any harm, right? They're just listening to your conversation, maybe, or maybe they are grabbing your credit card information, or maybe like what you type in terms of passwords and like those things. So it's basically spying on you. Okay, and that is what basically a spyware is, right? So any which ways, like I mean, there could be a lot of things such as these, and they all fall into the category of malware, right? Malware is what it is called, and basically it stands for malicious software. Any software which is malicious, right? The entire point is to uh, infect and break down your system such that the attacker can, gain access to it, right? Or something like that, right? Some on those lines. So yeah, basically this could be an attack vector. Okay, maybe a sophisticated attacker will may take this path. Okay, like the malware path. Of course, it requires a lot of technical know-how to execute these things. This is unlike your phishing and like those kind of things. Right? This is uh, actually very technical stuff to kind of deploy, and you need very technically sound people to be able to do this. Right, and finally, a very simple mechanism that could be used by the attacker is weak authentication. Okay, at your end, like your organization may use weak authentication, like I said, right? I mean, for example, a simple thing like password. Okay, you can set up very complex passwords. You could set up very small and funny and stupid things, right? Maybe like your employees are using their own names as password, and that happens, right? If you allow them, people will actually do this. Okay, whatever the conversation we are having right now, and however serious we are in organizations, people are not serious, right? And people will happily like use their birth dates, okay, and maybe their spouse names, and maybe if they are even own names, okay, like to keep it simple. I mean, of course, they are not really worried about the security until something bad happens. And but yeah, like this can be easily exploited, right? I mean, you would not even need like great technical know-how. I can simply grab some information on this particular user and try these different things as passwords, and uh, possibly with any good luck, yeah, we can like have access to these things, right? So basically somebody could essentially exploit uh, poorly designed authentication mechanisms. Okay, poorly designed authentication mechanisms, and that is why it is like we discussed, right? It is very necessary to have good policies in place. Okay, like good password policies, that you need to change your passwords regularly, right? Because let's say like somebody, so let's say you have a very complex password, okay, but somebody is trying to like in your organization, like somebody is trying to grab or like see your password every time physically. I'm just saying like they take care to notice what is the type or what is the password that you type, and possibly if it's a complex password they will not see it in one go. But if I view your typing every time, like what you type, I can try and memorize your password. That is why also you need to change your passwords regularly, right? So that nobody can keep a track of it, and yeah, like basically can uh, you know we can like possibly prevent it if we just have better security features in place, right? So yeah, these are some things that we wanted to discuss. Some other things as well as we kind of go along. We'll also build up on uh, firewalls basics, and like in the first place, I mean, we'll understand what firewall is and gradually make our way to the ASA, and then accordingly we'll of course be executing stuff and like those things. But yeah, some so these are some basic theory stuff that you kind of absolutely need to be aware of, because like if you plan on being a part of this industry, right? Some basic pointers, again I'll be sharing some notes in terms of PDF and stuff. Again, some very so all of this is pretty simple, nothing over the top complicated. Again, like I said, we do not need to literally get into how these things are done, because that's not our job, and we are not into hacking. We are kind of on the other side in terms of preventing stuff with, and we have those devices, right? We'll have those devices in place which will help us do these things, right? So, but yeah, this is something that you kind of have to know as a part of this industry when you're a part of it. All right, so this is where we'll stop for the day here. We'll again connect back tomorrow, and we'll continue with this journey. I'll be sharing some PDFs and like note stuff with you. Please go through them. Even this note stuff that I've written, I'll be sharing those also in the group. All right. So anything else before we close off for the day? Anything at all?
Nothing, thanks.
All right. So if there are no more queries, let's close off for the day. Let's meet up back again tomorrow. Bye-bye.
Sure. Thank you.
Yeah, sure. Thank you.
Bye-bye. All right. So this is day 2, right? This is our day 2. This is 4063. Cool, right? So let's begin. Okay, so we did discuss a lot of things yesterday. Okay, just to build on top of it a little more on that. So we learned that if somebody wants to attack our network, they have to do a reconnaissance, right? I mean, they'll have to know our network first, right? And only then they can decide on how to get through with an attack, right? I mean, of course, it's a planned thing. None of this goes just helter skelter, right? None of that ever happens like that. It is a pre-planned dynamic thing, right? That happens. Okay. That being said, let me see. Yeah. All right. So that being said, they probably need your IP address, right? Some attacker would need your IP addresses. I mean, what are you working with? Host names probably, right? If they can know their name, they know their host names of the devices that they want to attack. Again, it's going to be something important. If they can know our domain names, right, that is also something that may prove useful to the attackers. They also would want to know the software ports that are open, right? And so these are basically the TCP UDP ports that are open, and therefore it is always advisable to turn off ports that are not in use, right? Because these ports then act as backdoors, right? On the network part, we would kind of be required to scan our networks ourselves, I mean, first, and get to know what all ports and stuff are open so that we can close them down in case those are not needed, because they may end up serving as backdoors for the attackers. They might also want to scan and find operating system, right? Again, all of this is tied up to our previous discussion from yesterday, where they want to know what are the vulnerabilities, right? How is our system vulnerable? And to know those things, of course, they need to know a bunch of these things, right? So that they can pinpoint what all vulnerabilities are there, and they can exploit them accordingly, right? All of this that they want to do is certainly for that business. Now, to achieve all of these, right, they might use packet sniffers, okay, as they are called. So packet sniffers are basically softwares, either like softwares available, I mean, even for like free download and like stuff. These capture packets, right? So in any given network, what they would do is they can capture the packets and they can read out stuff, right, in those packets. Now, again, that is why we kind of say that we should always be encrypting stuff, right? Because anybody could get a packet sniffer somewhere, and anybody can try and tap into a network and read off stuff, right? If things are encrypted, yes, certainly it will be helpful that they will not be able to make sense out of data, right? So if you're sending information from one place to the other, right, anybody can actually sniff packets, right? Somebody sitting with their laptop here, and you're sending and receiving data between these devices, let's say A and B. yeah, anybody can of course do that. I mean, it's not a hard thing to do, to like sniff of packets, right? The only thing that you can do is, and of course you cannot even prevent this from happening. I mean, anybody can sniff your data because probably you're using the internet, and internet is a public network where everybody is just connected, right? Something, yes, something that could be beneficial is if you could encrypt your data, right? So even if they get hold of your data, they would not be able to read it, right? That is why we always emphasize on encrypting stuff and using protocols that have encryption in those, right? For example, as network administrators, you possibly want to have access to some routers or switches remotely. You could use telnet, right? But telnet is not something that is secured, right? Versus ssh is something which is secured, and it is something which is recommended, right? So that you can be using those things. The attackers could be using ping sweeps, right? So this basically does a ping on the entire network, right? ICMP packets are kind of generated, they're sent across the network, and from the responses, right? Responses, they kind of understand what the network kind of looks like. Okay, so some attacker sitting somewhere, okay, what they would do is they would send out ICMP packets, okay, like ping sweeps. Now, in response, of course, our devices would send something back, and based on those responses, they might understand what our network kind of looks like, right? So these are basically called as ping sweeps, and ICMP responses, right? So basically, they would be sending ICMP packets, and responses are generated, right? And they would kind of understand what our networks would kind of look like, correct? So yeah, this is something which is which can be done. The attackers may also do some port scans. Okay, so like I said, I mean, you may have different UDP. So based on your operating systems and the network that you're using, you may have a bunch of software ports, right? Of course, I'm not talking about the physical ports. You have your TCP and UDP, and a lot of ports might be open, right? Now attackers may find these out, okay, and they might see which ports are open, and they might use these to their advantage, right? They may serve as backdoors for them to get into our networks. They might run something called as port scans, and they scan the entire network for the ports that are open. At our end, in terms of security, yeah, therefore it is always good to close down ports which are not in use, right? You can do those things through firewalls. You can block out ports which are not in use, and you can prevent these kind of attacks, right? So there are of course softwares available again for these things. These softwares, of course, not difficult to get your hands on, right? I mean, these are available. Of course, they are not legal in many cases, but yeah, I mean, like of course, attackers do not care about the legality anyway. So yes, some software scans that people do, and they can find out what our ports are available. Now, yeah, so basically, they can do a lot of things. By the way, they can have something called as information queries be generated, and this would give them the host names, okay, on the network. Again, some simple softwares on the internet available just off the shelf would help in resolving these things. Okay, so they would know the host names as well. So that's again a good thing for them to launch an attack with. Uh, Again, DNS. So things related to the internet and the domain names. Let's say if somebody wants to get information uh, on some domain, right? So there is a registry which is called as Whois, right? And Whois basically has those DNS registries. This is a very good place to find out more information on the DNS entries. And yeah, like this is something which can be easily leveraged, right? There are some other softwares again for scanning. There's something called as Nmap, okay, which helps you run all these basic scans, by the way. I mean, of course, it's a free tool, by the way. It's I mean, it's of course also used for security people. I mean, people in security also use them to their advantage, and attackers use them to their advantage, right? So there is something called as Nmap, and they kind of run scans, and they can have a vulnerability scan all in all, right? So this is something that the reconnaissance can help with some attacker might do some recon, and they might guess, they might get these information, and it will help them launch some attacks. Yesterday we also discussed on access, right? I mean, of course, one of the major reasons somebody wants to attack you is to gain access, and these are basically called as access attackers, where of course they want to get hold of probably your password, right? I mean, that's the most important thing that they can get their hands on, because of course with this they would gain system access, right? Any particular system that is an asset for us can be compromised, of course, if the password is leaked, right? Pretty simple as that. So yeah, this basically can be done. Sometimes, like we discussed, you can have spoofing attacks. Okay, spoofing is like we discussed yesterday. Spoofing is uh, where you present yourself as somebody as like who you are not, like in terms of technical, PCs and like stuff, right? Like in terms of uh, like in terms of uh, like IP addresses and MAC, right? So let's say if like two devices are communicating, and what you could do is you could have somebody spoof themselves as a different device, right? In terms of IP addresses, in terms of MAC addresses. So let's say there are two devices A and B trying to communicate with one another. Some device C as an attacker, I mean, they can masquerade themselves as uh, maybe masking themselves as device A, device B on one side, and device A on the other side, and they could act, as somebody as they are not. Okay, again, in terms of some devices or person, they could be some kind of spoofing, right? So yeah, I mean, it could be that they are masquerading themselves as devices. Sometimes it is also that they spoof themselves as a person, right? Again, depending on what they are kind of spoofing and what they are looking into. We also learned yesterday that sessions, by the way, can be hijacked. Okay, we'll have a little more discussion on this. And session hijacking is basically playing around with the OSI model itself, right? We know that the OSI model exists, and it is the basis of communication for everything that happens on a given network. You can leverage things and the way the protocols kind of work to hijack sessions, right? Because when two devices are communicating with one another, they form a session between them, right? You could hijack them, and maybe some device C, okay, can hijack the session and begin communicating as somebody else, okay, like a spoof attack. And finally, of course, all of this can be done with malwares. Okay, so malwares, again, there are many malwares. There are different types of malwares. You could have viruses, right? Which viruses are specific on replicating themselves, and they do some kind of a harm. Okay, they possibly will wipe out some data, they will erase some data, they'll corrupt some data, something like that. We also know that there are something called as trojans, which again masquerade themselves as softwares as they are not, but then they do something else in the background. Okay, so you might download a software thinking it is something else, and in the background it just sits and does something else, right? Maybe it is spying on you, or maybe it is sending out information, or maybe even just looking into your network and stuff like that. Again, malware is just a large term. There could be various things, there could be many things. In fact, there could be something called as rootkits, right? So yeah, so basically malware, like, it's a huge umbrella term, right? Within it, like I said, there could be viruses, right? Now, virus, generally a virus would be something that kind of replicates, and it does some harm, right? It goes on replicating within your system. Maybe it is about, I mean, the entire purpose is to consume a lot of memory, to fill up your hard drive, or maybe even to harm something, right? So essentially, but they would harm or destroy something, corrupt something. That is their entire purpose. There could be trojans, right? So we kind of discussed that there is something called as trojans. Now, trojans are more of a silent type of stuff, right? These could be softwares, like I said, masquerading as something else. So they kind of form like backdoors. Okay, you probably would be the one who go ahead and install these things on your system, and they end up proving as backdoors that, or maybe they're sending something some information out. uh, Technically there could be something called as spywares, which again are not any of these things, but the entire thing is to spy on something that you're doing on your devices. Maybe they are collecting information on your traffic. Maybe they collect information on what you type, maybe the passwords or something like that, and many other things, right? So these can be spywares, these can be trojans, these can be viruses, and those kind of things. So yeah, I mean, like, there's a whole list of course malwares, but the entire stuff, I mean, it's malicious software. That is what it is essentially called. uh, and there could be many other things as well. Okay, so for example, we did discuss there is something called as a rootkit. All right, now rootkits are much more sophisticated. Okay, they kind of form as it hides into the like operating system. Deep in your operating system, it kind of would hide itself. And I mean, it's very hard to get rid of this thing. Okay, like, unless, I mean, if you so it's very stealthy is what I mean. It is very good at hiding itself. Even good antiviruses and stuff might not be able to detect rootkits. Okay, and but yeah, I mean, of course, they're there for a reason. And I mean, again, they might be sending out information. Maybe they are modifying your system behavior. Maybe they turn off the antivirus. Who knows? Because the entire thing is that they integrated with the operating system itself, right? And they're very hard to detect. And sometimes you might want to, I mean, you have to get rid of the entire operating system. I mean, like, you'll have to format the entire operating system just to get rid of it. So yes, I mean, that's kind of a thing that might affect you. Okay, so these are basically like rootkits, and these can be a problem. Okay, so yeah, I mean, like, this again, this is a type of attack. I mean, of course, rootkits are not easy to get into your system. Somebody might need some access to your system to get this to work. It's not easy, of course, to simply get like something like this into your system. But yeah, in case they do, I mean, this is essentially like what it is. Okay, so yes, that's like one other thing. Rootkits is something that might have tremendous damages on your system. Certainly it can. And yeah, like this of course can have a lot of issues. Now, in terms of man in the middle attack, right? We kind of discussed those things yesterday. There is something called as MITM attacks, which simply mean that this is a man in the middle attack, right? So basically, what this essentially means is, again, the same thing. What we kind of discussed a little earlier here. Somebody sitting in the middle of all of our communication, and gaining access to what is being communicated, right? Now they can leverage a lot of things, by the way. I mean, this is not one kind of an attack. They could be various things, by the way. Okay, for example, this could be on a physical level. Somebody actually connects themselves to, I mean, yeah, this is not always possible, but at the physical layer, for example, in the OSI model, there somebody could actually connect them to our selves physically. Of course, not easily something that can be done, but yeah, I mean, like, if somebody has physical access, right? And we discussed that yesterday. It's not necessary that attacker is some sitting across the world, right? I mean, they could be somebody who's from your office, and things like that. And yeah, I mean, like, this guy, if they have like physical access, they can actually connect themselves physically to our stuff. Now, if not that, on the data link layer, right? Again, I'm referring to the OSI model, right? So at the data link layer, what they could do is they could poison the ARP, right? Now, I hope you know what ARP is. ARP is Address Resolution Protocol, and this is a resolution protocol, right? In networking, you have a addresses, right? The network works on IP addresses, and but at the end of the day, you need to convert those IP addresses to MAC addresses, correct? You need to convert those IP addresses to MAC addresses, and like, what is the protocol that does this? Okay, so it's of course ARP. ARP converts the IP addresses to MAC addresses. But uh, what if you poison the ARP? Okay, like the ARP database. If you go ahead and if you uh, if you poison the ARP, meaning the database. Okay, so for example, there is some IP address, and it is binded to some other MAC address. What if you change the MAC address to something else? Right. This is exactly, by the way, like what happens with uh, with with the ARP poisoning, right? So what happens is somebody would poison the ARP cache, right, and would change the MAC address, bind it to a certain IP address, right? So this is basically ARP poisoning, as it is called, and certainly somebody could leverage this information, right? I mean, of the ARP and how it works. At network layer or the layer 3, you can of course manipulate the actual packets. Okay, you can manipulate the packets themselves. Okay, meaning of course you could you could change the IP addresses in the packets. Okay, meaning where they want to go and where they have come from. You can certainly change those things, and again, it could lead to an MITM attack. At the upper level, still, what you have is a session layer, right? At session layer, you know that it is the TLS, right, or the SSL sessions which are formed, right, between devices. Whenever you have devices which are communicating over TCP and UDP, and of course you have these sessions which are formed. Now somebody of course could hijack these sessions, okay, or somebody who's well informed of how these things work. Of course they could leverage themselves into manipulating, how these networks work, and they could of course like base an MITM attack based on this information or the session form. Basically they would be hijacking the session. And of course there is the application layer, right, which is there. And the application layer, of course, what you can do is somebody could infect the browser, right? For example, let's say you're running the browser and you're browsing something or maybe something like that. You could use a malware, right? And maybe it, instead of sending information to a particular, like a genuine destination, maybe it is relaying information to something else, right, or something like that. Again, this is kind of an MITM attack where you are trying to send somebody some information, but then it goes to somebody else because your browser is infected, right? So again, those things can happen. That is also a form of an MITM attack. There could be other things, by the way, apart from this, right? For example, there is something called as DNS, right? I hope everybody is aware of DNS. DNS essentially is again a resolution protocol, right? So for example, we did discuss the ARP kind of, right? I mean, what it does is basically it converts IP addresses to MAC addresses. On the internet, what you kind of need is something that converts the IP addresses to domain names, right? So for example, the domain name to IP addresses, right? So for example, let's say you type in google.com, right? You type in google.com, and of course, something has to translate this to an IP address, because the systems actually work on IP addresses and not domain names, right? Domain names in terms of google.com, for example, is just for our good reference, right? Because as human beings, we are more accustomed to using domain names rather than IP addresses. So there is something that is required that would convert domain names into IP addresses, and such a service is basically DNS, right? Domain name system. Now, domain name system is absolutely required when you want to browse the internet and stuff like that, right? Meaning you say google.com, and so, but what is google.com? Of course, it has to be translated into some IP address, and that thing is done by DNS, right? So initially your queries are sent out to a DNS service, right? They are the ones who convert your domain name into an IP address. And but what if somebody poisons this? Okay, what if like in the ERP stuff? Okay, what if my database itself is corrupted? Meaning, for a given domain name, there has to be a certain IP address, but what if the IP address is compromised? Okay, like last time, what if this thing is compromised? So last time, in terms of ARP, somebody compromised the MAC address. Can somebody not compromise the IP address for the domain name? Of course they can, right? And certainly, of course, this happens. So this is basically a DNS based attack, right? Somebody can poison your DNS queries or supply false DNS information. Okay, and this of course is a type of an attack, right? So somebody could supply false DNS responses. Okay, somebody could supply false DNS responses, and this is something that can happen. Yet still, right, that there's a very famous service which is called as DHCP, right? DHCP, of course, is the service that actually provides you with IP addresses, correct? So assuming, again, maybe like I said, I'll be assuming for the most part that I have freshers, although I know that most of you are working and this is a fairly simple service, but assuming maybe like somebody who's watching the recorded session doesn't really know, right? So basically, a DHCP thing, okay, a DHCP thing is basically a dynamic host configuration protocol, where you have a certain server, okay, it could be a router, by the way, any device, by the way, which is configured with the DHCP service, and this DHCP service, by the way, is responsible to provide your clients, okay, with IP addresses and the IP stack, in fact, the entire IP stack, meaning it will be providing you with IP addresses, it will be providing you with gateways, it will be providing you with DNS information. In fact, I mean, a ton of information can be provided just with the DHCP. Again, can not this be compromised? Of course it can be, right? What if somebody were to like compromise DHCP into giving out rogue IP addresses or rogue gateways and rogue DNS services, right? Would not our network be compromised? Certainly it will be, right? Of course it will be highly compromised, because IP address and the IP stack is something that you absolutely kind of need, right? And if you don't have those in the correct working order, this is gonna be a huge problem, right? Certainly it will be. So yeah, I mean, that's also kind of an attack where you have fake DHCP information or rogue DHCP servers, in fact, being installed on your network, right? Because it's a service, right? You can install this anywhere. Its only job is to give out IP addresses, right? Nothing hard to do. So you can have a rogue DHCP server with false information, right? Such that your devices are then configured incorrectly. And of course, you can imagine the mayhem and chaos that it creates, right? So yeah, these are some things which can really affect your network in a very bad way. I mean, in like tremendous ways, hard to recover from, right? So that's there. Yet still, right, we still discussed yesterday that apart from all of this, right, somewhere, I mean, these attacks that we kind of discuss are still more technical, right? They are kind of very technical, and somebody needs to still have a lot of technical details, a lot of technical know-how, and it's kind of difficult to deploy, right, these kind of attacks. But we also discussed yesterday that there is something called as a DOS attack, something as simple as pinging, right? I mean, if you have a server, right, if you have a very important server and it's serving some people, I mean, somebody could simply bombard this device with endless requests, and it could be a simple thing such as ping. In fact, earlier there was so I don't know if you know this, but there was something called as a ping of death. Okay, I don't know if you know this, but there was something called as the ping of death, and there was a certain size to the ping packet. Okay, like most operating systems kind of had this issue. Okay, like a bug I mean, of course, now it is patched and like stuff, but there was something called as a ping of depth, and you could send a very huge packet size of ping, and it would cause the operating system to crash. Okay, imagine just receiving some ping information and like crashing the entire operating system. And this was a kind of an attack in the like which used to be there. And I don't know if like some operating systems still have it, and of course this might still happen. But anyways, this is what I'm saying. So something as simple as pinging, right, can lead into a denial of service attack. And we did discuss, that there is something called as a distributed DOS attack, right, wherein it's not even now the like attacker themselves doing this business, right? I mean, they infect some other devices on the internet, and those other devices, based on certain triggers, would end up attacking the victim. In fact, the attacking devices themselves are also a victim, correct? So yeah, I mean, like it has really grown in terms of technical know-how. One important thing that I want to discuss is there is I mean, of course, it's also referred to something which is called as a reflection attack. Okay, so there is something called as a reflection attack. Now, what is a reflection attack? So in the reflection attack, what happens is, attacker, first of all, they spoof the source address. Okay, again, I mean, that is any which way is very obvious. Somebody who's attacking you will never use their actual source, right? Of course, they would not want to be traced. That's pretty obvious and pretty common sense. But yeah, let's just mention that as well. Okay, so basically the attacker spoofs the source address. Okay, the attacker spoofs the source address and sends the queries to something called as reflectors. Okay, so we kind of discussed yesterday that there are something called as botnets, right, or zombie devices, which themselves are victims, right? So they could be used as reflectors. Okay, I'll just get to that in a while. So attacker spoofs the source address and they send queries. Okay, they send queries to reflectors. Okay, so you can imagine this to be something like this. Okay, so you have maybe I'll take this space. Okay, so basically you have an attacker here. Okay, so this is some device A where you have this attacker guy. Okay, and they would of course spoof themselves, and what they would do is they would send their, they would send a trigger basically to a bunch of devices on the internet. Okay, and these are basically botnets, but technically together they are known as reflectors. So these devices, let's say like B, C, and D, okay, maybe are reflectors. Now at the trigger sent by the attacker, okay, at the trigger sent by the attacker, what would happen is they would go on to attack some victim device. Okay, they would go ahead and they would attack some victim device, and yeah, I mean, like that is basically like what happens. Okay, like yesterday. Okay, these are like botnets, these are like zombie devices. They would also be technically referred as reflectors. Okay, so even if the victim tries to trace like who the attacker was, of course they would never be able to reach the actual source, because any which ways, even if they do, I mean, it was spoofed, right? The address, the source address was spoofed whenever the attack was happening. So you would not know where the like where the attack was like coming from, right? You have no way of knowing it, by the way, right? And yeah, so basically attacker sends like spoofs the source address and sends the queries to reflectors, and the reflector in fact are the ones that execute the attack, right? So basically the reflectors, okay, the reflectors send. Now, by the way, this could also be in a way. So, for example, and this is an interesting case. Okay, hear me out. Okay, so what happens is, okay, like hear me out. This could be a very interesting case, like so. Okay, so when the attacker spoofs this address, okay, when the attacker when they spoof the address, they in fact use the address of the victim. Okay, They use the address of this victim guy, right? And they send in a query which demands a very big response. Okay, I hope you understand what I mean. So in fact, the reflectors think that it is the server who's asking for information. Okay, I hope you understand where I'm going with this. So the attacker in themselves, in fact, pose as the victim's device. Okay, and they send out a query. In response to that, I mean, of course, because they received a source address which is of the victim, they would go ahead and they would, of course, attack. I mean, they would send back a response to the actual device, right? I mean, to the address that you had spoofed off. And this would seem like a genuine communication, to your reflectors, and they go ahead and send the information, because to them it would be as if, like to the reflectors, it would be as if the victim asked for it. Okay. So yeah, I mean, like this is something that also can happen, meaning the reflectors would send a response based on the input that they received. They are not even thinking this is an attack, right? They assume that this is a genuine thing going on. Correct. So yeah, this could be a like an interesting case where this kind of something like this happens. By the way, this could also be something which is called as an amplified attack. Okay, so reflection attack is like one thing. You could also have something which is called as an amplified attack. Okay, now what is amplified attack? Now, amplified attack simply means that the attack is basically amplified, right? Meaning the responses required from the reflectors are, like I said, may be very large. Okay, so the attacker will take care to send some queries which will require very large responses. Okay, like and like I said, I mean, reflectors, to the reflectors, it will seem as if this was a very genuine thing which is happening. Correct. And so yeah, that is what is basically an amplified attack, wherein you probably do not even have a lot of botnets, but the reflectors are sending out huge chunks of information. Okay, so in the amplified attack, what you have is responses which are required by the reflectors to be very large. Okay, so required by the reflectors to be very large. Correct? Yes. So basically, that is what it is. Now, we also discussed, like in the previous case where we were discussing MITM attacks, we also discussed DHCP, by the way, right? And yeah, I mean, like DHCP. By the way, I mean, it does not even have to be a very sophisticated thing. Okay, like one of those things. Okay, basically, if I talk about DHCP attacks. Okay, if I talk about DHCP attacks, I mean, one of the things that we discussed was, yeah, I mean, you could have a rogue server, right? That is like one of the things that we discussed. You could have a rogue server be installed, and of course, as you can imagine, this is giving out. So basically, this is like a false. This is like a false server, right? I mean, the rogue server is essentially like a false DHCP server, which hands out all the wrong information, gateways, IP addresses, and stuff like that. And you can imagine the chaos, right? So that's one thing. This is like one thing that can happen. You could also not pull off something so technical. Okay, I mean, rogue DHCP server is like one big thing to do. You could in fact do a very simple starvation attack. Okay, so what is a starvation attack, by the way? Now you know that your DHCP server, whenever you install it, okay, so let's say again, this is your DHCP server, right? Let's say this is your DHCP server, and of course it is configured to give out IP address. And to make it simple, I'll assume that there is a class C network, right? Meaning probably, I don't know, maybe it is handing out IP addresses of 192.168.0.x, right? Meaning it can hand out a total of 1 to, let's say, 254 IP addresses. Correct? Meaning a total of 255 IP addresses. Now, what if I don't infect the DHCP server, by the way, this time? Okay, I don't in fact do anything with the DHCP server, by the way, right? So you have a certain LAN. In fact, what you do is you pose as a genuine client. Okay, and this is again a very interesting case, right? You are this attacker guy here, right? Maybe some device X, right? And what they basically do is they send out genuine queries. Okay, they send out, but of course which are false. Okay, but they pull out false queries to the DHCP server, and the DHCP server goes on responding and giving out IP addresses. Okay, and then what you do is you basically starve it of the IP addresses, meaning see, this IP address, I mean this DHCP server can only allow for 255 IP addresses. What if you kind of force it to give out all the 255 IP addresses? Then it is starved, right? I mean, it cannot hand out more IP addresses. It does not have those IP addresses, right? So what I mean to say is, let's say there was an attack, and this X guy, okay, pulled out all the 255 addresses. Okay, it went on giving false queries, and in response it got all the false IP addresses, and all of that. Now your DHCP is left with nothing. Okay, and what if there's a genuine query from this, let's say this device, I don't know, some genuine device B. Okay, now this genuine device B, when it asks for IP addresses, it will get nothing in return. Why? DHCP does not have any IP addresses left for you. Correct. So again, this is not, I mean, have we even touched the DHCP server? No, right? I mean, literally nothing that we have done on the DHCP server itself. But because it is so, okay, because what you have done is you have depleted it of IP addresses. This is an interesting case, right? I mean, you have starved it of all the IP addresses, right? So you basically here, what happens is the attacker basically sends false queries. Okay, you have false queries with false MAC addresses, right? Because IP addresses, when they're handed out, they are of course given out to a MAC address. Okay, so you have false queries with false MAC addresses, be given, and the DHCP goes on responding, right, and is depleted. So here, what happens is DHCP responds, and finally it is depleted. Okay, it is finally depleted. Okay, depleted of the IP addresses, and it can no longer serve you. Correct. So yeah, this is basically something that can also be pulled off, right? It's again like a thing. Okay, now we have been discussing. So these are again some type of attacks that can happen in a given network, and more sophisticated ones, like we discussed, right? I mean, there is something called as a rootkit, right? By the way, on those things, this falls under the malware category, like we discussed, right? This is like installed in the operating system, right? And it is very hard to detect. Like it can be detection is like very difficult. Okay, not even like maybe like even it may even bypass certain antiviruses. Okay, and yeah, it can actually like take control of the operating system because it is deeply integrated within the system. By the way, of course, this is not easy to get into your system, but if somebody does, yeah, I mean, it is fundamentally a very difficult thing to get rid of. Similar to rootkits, by the way, like on very similar lines, you also have something called as exploit kits. Okay, you have something called as exploit kits. Now, exploit kits are again like on similar lines with rootkits. They may be automated frameworks. Okay, so these are like automated like entire frameworks to discover and exploit vulnerabilities. Okay, so maybe they are deployed in your system, and they would just sit there and they behave in a very automated way to discover and exploit vulnerabilities on their own. Okay, meaning like nothing that they need from outside, and they would exploit the vulnerabilities. Okay, meaning they would go on scanning probably, and whenever they find something, okay, they will of course make good use of it. Now, this is generally based on some kind of scripting possibly maybe PHP or something like that. And uh, yeah, I mean, like they can be of course, as you can imagine, very disastrous, right? And this can basically end up doing a lot of various like stuff, right? So victim maybe is directed to send out exploit kits to some servers to be scanned for vulnerabilities. Okay, meaning like one system will try to then exploit some other systems. Maybe you have servers in your thing, and maybe it tries to gain advantage of that. So yeah, utterly disastrous as this can be. Okay, now one still more sophisticated, okay, could be some attacks based on something called as command injections. Okay, so there is an entire category of attacks which are kind of called as uh, command injections. Okay, now one of the things that we kind of discussed was, and I'm basically trying to be a little more technical than yesterday, as you can imagine, and see. Yesterday was just the first day, and I wanted to be a little like too basic, okay, in the discussion. I'm trying to kind of build on that. Although, again, our main motive would still be on protecting our systems, and not to dwell too much on on these things, right? This is of course not a hacking class. We are just trying to understand, like, these are some things that can happen, okay? And you might repeatedly go on encountering these words and stuff in your environment, although you may or may not be dealing with them directly, right? We are network security engineers, particularly in line with the course. We are more to do with network security, as it is called, right? But yeah, these things will be encountered by you ever so often, and you kind of need to know these words, at least in very simple sense, as to what they mean. You may or may not be directly dealing with them, depending on the case, right? So yeah, okay, any which ways, so command injection, we kind of discussed one of the things yesterday, where this could be something which is called as an SQL injection, right? What that basically means is, SQL, like I said yesterday, right? I mean, this is like the gold standard language to interface with databases, right? So there is some kind of a database management system which always will be there. I mean, you have to store your usernames, passwords somewhere. Maybe you have websites to log into, and you will have your DBMSs, right? And to interact with those things, whether it is some like some website or maybe like something like that, and it always would interact in the background with some kind of a DBMS, right? And to do that, what you would have is structured query language, right? Now, like I said yesterday, SQL injection works exploiting the way SQL works, by the way. SQL has some known bugs, and of course, it is not a permanent thing. Developers, can take good care of it at their end. I mean, it is something again that they have to take care of it. The developers would. Good designing in terms of SQL, good web development, right? And those things would help. Okay. But yeah, I'm just saying, like, SQL can be exploited in a number of ways, which will end up spewing out all the data. Okay, like you put in some weird queries, and these are known queries. These are well-known queries, by the way, right now. Okay, and even if your systems were protected, somebody would still try this out. Okay, just assuming that you did not patch this thing up. Okay, and sometimes it is, right? Sometimes people don't take good care of business, right? And this is what happens. So anyway, these are like some bugs, or you could say that these are kind of like invalid SQL queries, but they end up giving out information, right? And I mean, of course, these can be taken off care of by the developers themselves. Nothing specifically that you can do about it, but yeah, these are some things that also happen. There might be something called as XSS. Okay, so this XSS, you might have heard of this term, or maybe like you have you may have come across this. So what is XSS, by the way? So XSS is, it stands for cross site scripting. Okay, X here actually stands for cross, right? So cross site scripting, and this is a very interesting thing, by the way. Now what really happens here is, you Okay, so let's imagine this. Okay, let's imagine this scenario. So let's say there is a particular user. Okay, and they are a genuine user. Essentially, we'll call this as the victim. Okay, victim V. Now what they want to do is they want to browse something on a certain server, right? A pretty genuine case as to like what can happen, right? Yeah. So this server is a very genuine server. Nothing like malicious about the server directly. Okay, but then what happens is you could have some attacker. Okay, and what they would do is they would install some scripts. Okay, they would install some scripts onto a genuine server. Okay, so without you knowing anything specific, you would simply be browsing stuff on your server, but malicious scripts are running on the server itself. Okay, and they would make maybe your browser do some weird things and may give out information based on your cookies, maybe based on the passwords and the username that you used, and things like that, right? So basically, you as a client are doing nothing out of the ordinary. The server, by the way, is not doing anything of the out of the ordinary, but the scripts, okay, the scripts that the attacker has installed, okay, that is making stuff do weird things. Okay, so whenever you as a victim browse this server or something like that, there are malicious scripts that are running. Okay, you have malicious scripts running. Okay, so you have malicious scripts that runs like on the server itself. Okay, so yeah, this is something that can happen. Okay, and there is still something that is on similar lines, but it is called as cross-site request forgery. Okay, CSRF, which stands for cross-site request forgery, right? So again, it is on very similar lines. You uh, you may send like the setup is the same, right? There is an attacker who has compromised a genuine server, and in your case, maybe okay, or maybe based on your browser or some scripts installed in your device. Okay, you might end up sending some weird requests to the server, and the web server and the web browser like performs some undesired action. Okay, so it could be like various things happening here. So this is cross-site forgery, which is kind of very similar to what we kind of discussed. But here the thing is that you send out some undesired queries without you knowing. Okay, like as a victim, you send some undesired queries. Okay, which may end up like pulling out some information or sending some information in the browser, and then the browser sends some information back to something else, and just like that, I mean, like the entire system is kind of compromised, right? So yeah, even here, I mean, like those of course things can sort of happen. This is something that like keeps on happening. Now, all of this is kind of a general discussion that we had, coupled with what we discussed yesterday, and still yet, right? I mean, still on the other side, I mean, what you can have is so right now a lot of things are moving onto the cloud, right? You have a lot of things moving onto the cloud, and I mean, yeah, based on the cloud stuff, of course, what you can have is similar kind of attacks. I mean, of course, the attacks kind of remain the same, okay, but the nature of your premises has kind of changed, right? Because now you of course have cloud and everybody's moving to the cloud, right? And it sometimes makes sense in terms of costs, right? And that is the reason. Now, when you talk about the cloud can be of various types, right? So you can have like a private cloud. Okay, so private cloud is basically majorly things that are under your control, right? It is not a public cloud. it is your private cloud, and you have major access to a lot of things. Okay, maybe they are on premises, or maybe even you could have some off premises things. Okay, so it is not necessary that you have everything on premise, but you have maybe like on premise thing, or maybe even like some part of it is off premises. Okay, but you control a major, in fact the most part of it, right? There would be of course a cloud service provider. I mean, you would still have a cloud service provider, a CSP, which helps you get things done, but you control most of your things. Okay, so you control like a major portion of everything that is happening. You control the assets, you control the network, how it happens, and like a major portion of the network is something that you kind of control very specifically. All right. Uh, of course, when you have the private cloud, the cost is kind of more, right? Because the maintenance required, because the team that is required, the expertise required, right, and so on and so forth. The maintenance and like all these things put together will have a huge impact on the cost. So private cloud, while it gives you a lot more control and security over your cloud infrastructure, this would maybe, okay, like of course it depends on a lot of other things, but it may prove very costly to you. And therefore what you have is the public cloud. Okay, so essentially what you would do is you would you would put everything on the responsibilities would be operated by a third party. So you would have a third party cloud service provider. Okay, and you would have a third party CSP, meaning a cloud service provider such as like Microsoft, Google, or Amazon, right? AWS, by the way, right? And they would be taking care of the entire thing. Now, in many cases, uh, this is a little cost effective, okay, because of the subscription nature of things. And like I said, it depends on what you're dealing with. Okay, there is no like one size fits all kind of thing there. I mean, it is never the case, in fact, for anything. But yeah, I mean, so like you have these large companies taking care of their things, and they already have their infrastructure, right? So this would be the most cost effective, but it is also less secured, right? Because you have everything on the cloud, and you do not control a major portion of it. I mean, of course, whatever happens inside Amazon or Google or Microsoft, you have no control over it as when you had it in your private network, right? So yeah, I mean, like it is like a give and take. The cost is fairly effective. You have those scalabilities, you have those reachabilities that you possibly would not have with the private cloud. But yeah, I mean, it can make things less secured, and also like these services are kind of like a hot target for attacks, right? I mean, being Microsoft, Google, and Amazon, and although they are huge firms, I mean, of course, they are vulnerable to attacks, and these things keep on happening, right? Ever so much there is something in the news, that these things do happen, of course. Now, therefore, a give and take between these two things would be the hybrid cloud. Okay, so hybrid cloud is kind of somewhere between the private and the public, in the sense that you may not want to put everything on the public cloud. Okay, so maybe, okay, just saying that maybe as an organization you decide that everything related to your data, okay, let's host it on a private cloud. Okay, so my data being the most important asset to me, I don't want to hand it over to even Microsoft or Google or whatever that may be. Okay, and the rest of the network, okay, meaning like various servers, the network like portion of it, and like other assets. Okay, so probably like everything else, maybe like all other assets are something that you feel that the public cloud can handle, and such is your network, right? So as you can see, it is like a mixture of the private and the public cloud, right? And therefore this is known as the hybrid cloud, right? Hybrid cloud is like a type of cloud computing that combines on-premises stuff of benefits of a private cloud, and then you would have certain things on the public cloud, right? So it gives you a little more control than what you have in the public nature of things. So it's a combination, basically, you could say, right? It's a combination of the like both the best of the both worlds. Okay, combinations of uh, best of private and the public, right? Now, yeah, this is just a basic description that I wanted to give you in terms of public, private, and like hybrid cloud. But in terms of threats, right? In terms of threats, you still have those similar things, right? I mean, yeah, that's the basic definition of it. But of course, we want to talk in terms of security, right? I mean, in terms of the threats that pose a challenge to us. Uh, Again, on similar lines to what we discussed, there is nothing new, by the way. Like all these things that we kind of discuss also play out here. Okay, so for example, a major problem with cloud stuff is misconfigurations. Okay, when you do not configure things correctly, and we have discussed this, by the way, like in like on premises stuff, we have discussed these things before. Misconfiguration is like one of the major things that leads to attacks happening, right? So it is yeah, I mean, certainly somebody is attacking you, but that is only possible or which was made possible because you misconfigured things. Okay, you did not configure things correctly and you left some backdoors open, or maybe some vulnerabilities open, and that is how the misconfigurations kind of created a problem. A major problem with cloud also, because cloud is cloud, right? Cloud is like the most important feature of cloud is that it is accessible from anywhere and everywhere, right? But this benefit can also lead to a lot of problems, and particularly the unauthorized access problem. Okay, the unauthorized access issues. And yeah, I mean, you can I mean, this is of course when somebody like gains access to something because of a lost password, or maybe somebody, because this is easier to do, right? Because the cloud is any which way is available on the internet, and somebody gaining access to your passwords, or because of the weak passwords, or maybe they stole the credentials, or maybe there's something unsecured in your protocol level, right? And of course these things can really impact like stuff, right? You could also have literally like hijacking of your accounts, right? I mean, right, so somebody, maybe they're doing phishing, or maybe something like that, and they, or basically again they steal your password. Okay, and then they hijack your account, right? Or maybe they do something with a session or something like that, right? So of course when they have this, of course they control a major part of the cloud asset, because it's anyway there in the cloud, and this could lead to a lot of commotion and chaos, right? Particularly again with cloud, there is always a huge threat to data itself, right? And that is why, like we discussed, the hybrid cloud any which ways, right? And I specifically gave you an example where the data, okay, you want to probably want to keep it to yourself, not even you want to let it out to Amazon or something like that, although they are a huge firm, and but the data is data, right? I mean, data is like super important uh, in our world at the moment, right? Data, you do not want data to be compromised. Everything else probably can be replaced, like I said earlier, but not data, right? So data loss is, by the way, it could also be accidental, right? uh, I mean, what if you store something on the public cloud, and like something happens to the public cloud, and these things are not new, by the way, right? There have been cases where people have stored stuff. Even like I can give you like simple examples. Maybe like somebody stored something on I don't know, maybe like Google Drive or the OneDrive, and and then they found that the data was lost, right? Yeah, makes, so what happens then? Okay, of course then there has to be policies, and of course you have to go through them, and you have to sit down with your cloud service provider, and I mean, you have to discuss these things through, right? uh, if you're a client, of course, to them. And so they can be accidental losses of data, there can be intentional deletion, corruption of data, or it can be made unavailable, right? Or there could be natural disasters, right? Or there could be hardware failures, right? Malicious attacks or whatever that may be. So there can be a lot of things. There could be a lot of data losses in various regards. Okay, there could be a lot of things in I mean, of course, in terms of security, of course, we are more concerned with the data breaches in particular sense, where data is accessed or copied or transmitted unauthorized, right? I mean, that is where the problem lies. And yeah, that's our major concern, particularly if the data is financial or some intellectual property or like something like that. Now, one important thing still is with the cloud stuff. Yeah, I mean, there is always a possibility of denial of service attacks, right? Which we have kind of discussed in a number of ways, and the same things apply to the cloud, right? So, and in fact, more, because everything is on the cloud. It's way more easier to uh, disrupt these services because they can prove as hot targets, right? In the cloud market, it's or the cloud industry, should I say? It's uh, like you have things on the cloud already, right? So it's kind of easy, to kind of uh, target them ever so much, because cloud by nature, of course, is always available, right? That is basically what cloud means. It is always available online, and it's simply easier to kind of attack on, right? So but yeah, these are some basic things that I wanted to get through in terms of the types of attacks and stuff, so that you know a little better. Okay, in terms when these things are discussed, when you are in the networking industry, right? I mean, these words, these terms, you will ever encounter them ever so much, again and again, on and on. And yeah, having a little knowledge of these things kind of helps. Okay, again, we do not really need to deep dive into them, uh, particularly if you're new to this industry, because I mean, like, not everything needs to be known. It's okay. I mean, like, we are more focused on hardening our network and protecting our network rather than understanding the hacking part of it, right? Like, our devices do them for us. Our job would be to manage our devices, right? Our focus would be all of that all the time. But yeah, anyway, I wanted to get this through. Any doubts, any queries on this? Anything at all?
Okay.
All right, let's take a short break then. Okay, let's take a very short break, 10 minutes. Let's come back and discuss specific things on I mean, in terms of general firewalls, right? What are firewalls? What are you expecting in terms of, like I said earlier as well, right? One of our students said that they were dealing with Palo Alto firewall, and I said, like, they're very similar. Like, in terms of firewalls, you'll see they have very common features. Okay, and that is why you have a very fragmented market, and there's no market leader as such, right? But what are those things? What are those services? Okay, what essentially is a firewall is something that we want to discuss today at least. And like I said, next weekend we'll actually start building on the Cisco like framework of things, starting with ASM, right? All of that, yes. But let's take a short break before that. 10 minutes, all right? Let's come back in 10 minutes. All right. So what we want to do now is, so we kind of laid a very good, background of kind of attacks and like things that you may encounter in our domain, right, of industry, and yeah. So all of that is fine. But then, like I said, we'll have to focus on our things as well, right? So our major job is to focus on firewalls, although there are some other devices, but again, they can be categorized as different types of firewalls. So what we want to know first is, yeah, like, what then is a firewall, right? I mean, that's the most obvious question. And what are the general capabilities that you should encounter or will encounter in most cases, right? Given that you have a bunch of firewalls out there in the market, in the industry right now. So what is a firewall, and what are we expecting it to do, right? Let's understand all of those. right? So this is where we discuss, our firewall stuff, the generics first, right? All right. So yeah, let's get to it, right? So basically, firewall. Now, so what is a firewall, right? Firewall is a network security system, right, that monitors and controls incoming and outgoing traffic. That is what it is, right? So if so, like just in case, if I wanted to describe what a firewall is in terms of a schematic, so let's say you are an organization, right, and this represents your organization, some organization, I don't know, maybe ABC. Now you probably want to connect with the larger other networks, maybe some other network, or maybe even with the internet. Okay, because of course that is something that you will be required to do. Now, generally, what you would have to do is you would have to have some sort of a security, right? Because see, the entire thing is that the ABC network of yours, right, your own organization, is something which is secure, right? Probably, I mean, we are assuming. Internet isn't, right? In other words, I could say like, your ABC network is a private network, right? The internet isn't, it is a public network, and you might want to control what goes in and out to the public network, right? This is an entirely like what it is, right? So you want to deploy something like a firewall, which would then uh, control all the traffic and monitor all the traffic that is going in and coming out of this device, right? That is essentially what a firewall kind of does, right? That is what I mean, it's a security system, right? Firewalls, although they have the capacity of like routers and stuff, their main job is not to have you get be or their main job is not to deliver connectivity, right? Although of course they can do it, right? I mean, they act like routers, they can act like a lot of other things, but they have their advanced IP services stuff going on and all those things, but again, that is not the core objective of deploying a firewall, right? Firewalls are firewalls, and what they essentially should be doing is protecting you, right? So whatever goes in and out of your network, they kind of monitor and they can control it, right? That is what it is. So firewall is basically a network security system. Okay, it's a network security system. By the way, it could be a service, right? And I'll get to that in a while. So it need not, by the way, it need not be a hardware, by the way. Okay, I'll just come to that in a moment, but that is what also it can be, right? So network security system where like the major role, right, it would be monitoring and control, right? It would be monitoring and control of the traffic, right? So you want to monitor and control the traffic that goes in and out of the thing. See, now the thing is, see, firewall actually is a service. Okay, firewall actually is a service, right? It's a service. Just give me a second. Yeah. Okay. So basically, firewall, of course, is a service, right? Meaning, see, if I wanted to, I could also use my router as a firewall. Okay, it would not be a very good firewall, by the way, but I mean, yeah, I mean, like, right, but something that can monitor my traffic and control my traffic, right, essentially is a firewall. So firewalls could be hardware based, or they could be software based, right? One simple example I can give you, of course, is so for example, let's say at my home network, right, or your home network, maybe you do not really have a hardware based firewall. Okay, or you could be, or you could have, even your routers nowadays, by the way, have these features, right, where you can control traffic and monitor traffic and you can do those things. But that's the entire point, right? That's the entire point that I'm trying to get to. Anything that can control, so maybe your this home wireless access point that you have, right? Technically, I mean, that is what it is called, but generally people just call this as a router nowadays. Now but this home device of yours, right, I mean, if you have a sophisticated one, you will see that it has some firewall services as well, right? So is it not a firewall? Of course it is, right? Because it can do those things. But by the way, on the other hand, what I want to mean to say is, let's say even if you were not deploying that, your home device, okay, doesn't it have a software firewall? Right, of course it does, right? Your Windows probably, I'm not sure the Mac thing, how it operates, and have not used a lot of Mac systems. I mean, I do know the operating system, but I'm not sure of the firewalls and like stuff that it has on. The Unix systems have it, so I'm assuming Macintosh also has it, but like who knows? Okay, I'm not very specific of it. But Windows, because I'm using Windows, I know that there's a Defender firewall that runs right now, right, on my system. You could also go ahead and deploy some other software-based firewalls, and they do the same thing, right? Anything that controls and monitor traffics or traffic is basically is a firewall, right? That is essentially what it is. In fact, okay, like I said, I mean, on the other hand, you could maybe just have a router in your network, right? So let's say you have a router in your network, and everybody of you probably have heard of the word ACL, right? Access control list. Yeah, what are you doing with the ACL, right? You're essentially using it as a firewall, not a very good one, as you will see. We'll have some discussion about this, by the way, in this section. That is the entire point. But yeah, when you do deploy ACL on a given router, that is what it is doing. It is monitoring and controlling traffic, right? It is a firewall, not a very good one, but yeah, this is what it is, right? Firewall essentially is this thing. Okay, so I just want you to broaden your scope of understanding is what I mean. Okay, so this is what a firewall is. Now, okay, so right now, I mean, because everything like we discussed, right? I mean, we started off a conversation saying we have large modern networks, right? Like in the first day of the conversation, if you remember, we have very large networks which are heavily inclined on being interconnected with the world, right? Therefore, nowadays firewalls are a integral part of your network. I mean, they have to be there. They are not a luxury as of now. Every network is kind of supposed to have this because everybody is on the internet, and there are more risks more than ever, right? And it is like an essential part of the network security system, right? And even so, like I said, I mean, it's not even like it's not even enterprise right now. That are only supposed to have this thing. Okay, what's happening? All right. Yeah. All right. So it's not only enterprise. Okay, not only enterprise network, but even in home context, right? I mean, you generally have some kind of firewall, and by the way, that is what this is all about, right? Like I said, I mean, you have software-based firewalls at the end, even if not some hardware-based stuff, correct? So this is essentially, I mean, this is what firewalls are. So firewalls, all in all, okay, should be able to do these two things that we discussed, right? They should be able to monitor traffic. Okay, they should be able to something weird is going on. Just give me a second. I'm unable to select pens correctly for some reason. Yeah. All right. So it has to like all firewalls have to somehow monitor things correctly. Okay. They should be able to filter stuff, right? In a way, what we mean to say is control, right? So there has to be some sort of a filtering mechanism. And generally, when I say filtering, it is essentially it is like either, I mean, like what can you do with filtering, right? So either it could be like you're blocking some things, okay, or you are allowing some things. More technical words are, by the way, permit and like deny when you talk about firewalls, but yeah, that is what they mean, right? So you're blocking some things, you're allowing some things, and monitoring is just monitoring, right? So everything that goes in and out of a network is something that you kind of want to have a tap on, right? So a firewall should be able to do these things: monitor your entire network, all the traffic, filtering. I mean, of course, filtering is basis on some rules, right? So you define some rules, and based on these rules, you end up blocking and denying things. Maybe I should write it the opposite way, right? So filtering basically simply means that you have some kind of a rule, okay, or a defined set of rules, security protocols, okay, where these rules finally would end up, you know, filtering stuff. Okay, what that basically means is like blocking or allowing things, right? That is essentially what that is. Right now, some other terms that you kind of need to be aware of when, like this is what a firewall does, by the way, right? This is essentially what a firewall does. But in terms of firewalls, you kind of need to be aware of certain jargons and words, okay, possibly if you want to call them. Okay, so this private and the public network that we spoke of are exactly what they are, but they would be, I mean, it would be better if we kind of define them as probably as these. Okay, so your private network, okay, is always secured, right? And it's kind of always referred to as the inside network. Okay, like in general cases, when you're discussing firewalls and stuff, this is what is called as the inside network. The public network is obviously always called as the outside network because it is outside your organization, right? So you have inside network, you have outside network. Sometimes the inside network is also referred to as the trusted network, right? Trusted because of course it is trusted. It is something that belongs to you, right? And therefore it is also referred to as this trusted network. Uh, the outside network is also sometimes referred to as the untrusted network, right? Because of course it is outside and you don't know what's going on there, right? So it's referred to as the untrusted network or the outside network. Sometimes, of course, by the way, of course, I mean, in the very same context, sometimes these are also referred to as internal network and external network, but they mean like in the same context of things, right? So external, untrusted, outside network means your public internet and like those kind of things outside your organization. Internal, trusted, inside network kind of refers to the internal side of things, right? My own side of things, correct? That is what it kind of means, correct? So yeah, that's basically what it is. And you have this firewall which is kind of a like a barrier, right, sitting in between you know, these two networks, and essentially it is trying to do all these things that we kind of discussed, right? Very simple things in terms of understanding, but then of course it builds upon those things gradually, right, as you will see. Okay, so all the malicious activity that goes around, or that it feels, and I'll define the word, why am I saying the word feels in a while, right? So they can be viewed as gated borders, or in a way they are gateways. Okay, like routers, they are, firewalls are kind of gateways, because as you can see, it's like a gateway sitting between my internal network and my external network, and it can permit or prohibit traffic, right? That is what basically firewalls essentially are. This in its very basic sense is something that you should be able to define, being somebody who's a part of this industry, right? Okay, let's carry on now. So what does a firewall exactly do? I mean, like, of course we have defined some basic stuff, and let me just say oversee here. Okay, monitoring just means oversee here. All right, so in terms of features, right, what are we expecting? Like I said, I mean, firewalls are many, by the way, in our industry right now, and but they have very similar features, right? And that's why the reason that you do not have a absolute market leader, okay, unless we have something that really changes all of a sudden, and like everything, like the landscape. Until then, I mean, it's just like everybody having about, give or take, 20% of the like the market industry. If you were to go to the internet, and that is what you will see, right? You have so like if I were to make like a pie chart of it, okay, so if I ever made you know, like a pie chart of it, it would all be you know, like all these vendors that you see, okay, all the major vendors, of course I'm saying, like Cisco, Palo Alto, and Firepoint and whatnot. And of course it keeps on fluctuating. You do not have a clear, I mean, of course these are not stagnant stuff, it ever keeps on changing. But when you see those things, you'll always see that everybody's like close to 20%, give or take. It keeps on changing a bit, and that is what it is. And this is basically because the features are these features. I mean, it's literally these same features that you have on these devices, and it's kind of a nice thing because although the GUI and of course the engine of the firewall kind of changes, but the features remain the same. And that's a good thing about the industry, because it's fairly easy to switch between devices. Okay, for example, let's say I'm working on Cisco right now, and you would ask me to like do something on Palo Alto. It would not. It is honestly not a big task. I mean, it's very similar. The GUI kind of changes, but works very similar to all the concepts that we will discuss in this class, right? Okay, any which ways, let's come back to our topic. So features. Okay, now features, of course, the most important feature, of course, for any given firewall is basically packet filtering. Okay, that is what we kind of also discussed, yeah, like on the top right now, right? I mean, filtering, monitoring is something that a firewall essentially does. So packet filtering is something that it should be able to do, and what this basically means is that it should be able to inspect traffic. And when I say traffic, of course, it is packets, right? It should be able to inspect traffics of the data that is passing through them, and they of course have rules, right? Based on the rules, then they will decide whether or not to allow or maybe deny the packet or block the packet in very simple language, right? So they should be able to inspect the packets. Then you have rules defined, and based on the rules, of course, you will end up allowing or blocking things. Okay, yeah, that's fine. I mean, like that is basically like what it is. However, these filtering, okay, they can be different things. Okay, so for example, what do I mean? Okay, so this filtering, okay, and this is a very important thing. Please hear me out, like very attentively. Okay, so and based on this, of course, the firewall and its types kind of changes. Okay, so what you can have is something which is called as stateless filtering. Okay, now what is stateless filtering, by the way? So stateless filtering is very simple filtering. Okay, stateless filtering is basically inspecting the packet. Yes, that is happening. You have some rules, of course, that is also there, but they do not understand the context awareness of what is happening. Okay, in very simple language, stateless filtering simply works on like dumb rules. Okay, for example, let's say on the basis of IP addresses. Okay, meaning I tell the firewall that certain IP addresses are allowed, certain IP addresses are not allowed. Simple as that. Or maybe even port numbers, right? Maybe even port numbers, right? So yeah, based on these things, the firewall will take certain actions. In fact, by the way, that is why I said, when you have ACL deployed on a router, okay, I mean, that is what the router is now behaving like a firewall, and it does. Although, okay, if you were to technically classify it, it would be a stateless firewall. Okay, why? Because it can only account for IP addresses and some port numbers. Okay, it doesn't really understand a lot of things. If it sees those IP addresses and port numbers coming through, or somebody trying to connect with it, I mean, it will take actions accordingly, right? That is what an ACL, by the way, is what it does, right? So if you ever deployed an ACL on a given router, yeah, it's a stateless firewall, right? It's a stateless firewall. Not like I said, it's not a good firewall, but it's a firewall, right? So stateless firewalls are pretty dumb stuff. So you have basically rules, okay, rules defined on the terms of IP addresses, and you have ports, right? You have ports, right? And basically, like, these two things would be defined in some rules, and the firewall will take actions based on those rules, right? So basically, something like this, right? You have, and again, I somehow cannot select the pen, kind of weird. Okay. All right. Yeah. Okay. And the full screen, it kind of doesn't behave the way I want it to. Okay. So basically, let's say like this is a firewall, right? This is a firewall, and let's say some traffic is trying to go through the firewall. What it will do is, if it is a stateless firewall, it can simply check for information, right? I mean, check for information in terms of an IP address and in terms of port numbers. If it follows those rules, I mean, of course, it will be allowed. Let's say if it does not, I mean, it does not fall into this here, like the policies, it will end up blocking it. Correct? right? So basically that is essentially what it is, but this is not a very good firewall. I mean, this is essentially not what you term as a very good firewall, right? And the reason is pretty simple, because this thing, okay, this thing would lack any context awareness. Okay, I'll get to this in a while, what this actually means. Okay, so it does not, I mean, it is not aware of context awareness. What does this mean? See, these type of firewalls can be easily spoofed. Okay, what do I mean? So let's say in your rules you have allowed some kind of an IP address. Okay, let's just imagine that to be the case. Okay, maybe you have a firewall, you have allowed maybe the network of 13.0.0.0, okay, /8. Okay, maybe because it is something that belongs to your organization. It's of course outside your environment, but this is something that you have allowed. Correct. Maybe something like that. Okay. Now, however, this belongs to outside your organization, right? And see, what would happen is if somebody were to spoof the source address, okay, maybe like there's an attacker like sitting somewhere. Okay, this attacker sitting on the outside network, and let's say they spoof the address and maybe they call them as like 13.0.0.1 or something. Yeah, I mean, it's gonna go through, right? I mean, it's just gonna go through. Now, why do I say this and this kind of, and you would say like, okay, but then what is the firewall supposed to do? I mean, because the rules allow this, I mean, shouldn't it be allowed any which ways? No. Okay, you will see that stateful firewalls would still not allow this to happen. Okay, I'll tell you why when we discuss stateful firewalls. But this is kind of a problem with stateless firewalls. They do not understand the context of things happening in the network. They simply work on some basic rules. Okay, some basic rules, and they are not very good at filtering stuff intelligently. Okay, so they work on some like some dumb rules. Okay, like whatever the rules that you have defined, and they lack the context awareness of things, and they may not be very effective at very complex threats. Okay, they would simply not be, so they are not really effective against complex threats. Okay, so against complex threats they are not very good in terms of their working. All right, now this being said, okay, so they would of course have their packet analysis. They'll basically be so the way this works, right? So they'll have their analysis of the packets, and in which basically they will see the packet's source, destination, and some other parameters, right? So this will generally work like so. Okay, so basically they these kind of firewalls, they possibly will look into the source IP address, right? And let me just call this as a packet analysis or this analysis. So what they'll be looking into is like the source IP, right? And they'll probably look into the destination IP. Okay, they might also look into source port numbers. Okay, again, I mean software ports, and they'll look into destination port numbers. But that's about it, right? Stateless firewalls can only do these things. And by the way, something as simple as this, of course, you could also deploy on a router, like I said, right? And it would still be a stateless firewall. It would be a firewall, right? So you have rule-based filtering, and based on these things, right? The source IP address, the destination IP address, the source port, and the destination port, things are allowed in or not, but they do not really have any context awareness. Okay, so they do not really track the communication that is going through. Okay, meaning they would not know if a communication is already existing. Okay, and I'll get to that when we discuss like the stateful firewalls. So they do a very bare bone business, and I mean therefore they're not a very effective thing, right? That is what a stateless firewall essentially is. They have rules based on these things, and but that's about literally it. I mean, you have rule based on these stuffs, and you would essentially be ending up blocking stuff or allowing stuff based on these things. But then the newer firewalls do not behave like this, right? What you have is nowadays, what you have is something called as stateful firewalls. By the way, like now firewalls are very sophisticated, as you will kind of see with our discussion here. and the discussion that we'll have in the next class. But firewalls nowadays are very sophisticated, okay, in a number of ways. So any which ways, the newer firewalls have something in them which is called a stateful inspection. Okay, so stateful inspection, what is this, by the way? So these stateful inspections, they kind of understand the context awareness of things. Okay, meaning when they view traffic, they are aware of the context of communication that is taking place. Okay, what do we mean by this, by the way? Okay, so let's say, okay, like we have our inside network. Okay, let's just call this inside network, and you have some client here. Okay, now let's say it is communicating with some server on the outside. Okay, there is an ongoing communication, and yeah, I mean, of course, probably it is going through some firewall. Correct. Now this firewall would, I mean, if it's a if it's a stateful firewall, it would know that this communication is happening back and forth. Okay, how it can keep a track of these TCP UDP sessions. Okay, the TCP UDP sessions that take place, it is literally aware of like who started the communication, who's receiving the communication, in case somebody replied back. Okay, in case, let's say, this server replied back, it would know that this is a reply. This is not some initiation of the connection. Okay, it would know that this is not an initiation of the connection. This is the server responding because somebody requested something. Okay, of course, how do you know it? Because these TCP UDP sessions, they have like numberings in them, right? In very simple language. Like when you ask for something, and in return when you get a message, I mean, you have some like numbers that are like in them, and through those numbers they are aware of these sessions, the TCP UDP sessions, right? So they can understand the TCP UDP streams, okay, and they are well aware of the context that is taking place. Okay, so in the first case, like I said, right, I mean, somebody just spoofed themselves to be like, this 13.0.0.1 guy, correct? This above diagram that I'm referring to. Okay, this one. Okay, so where somebody spoofed themselves as 13.0.0.1, and because it was a stateless firewall, they could just get in. Would that be the case in this server? No. Okay, I'll tell you why. So basically, when, let's say, some certain server, even if it be in the allowed list, in like some cases, again, that depends on what all the rules that you have specified and stuff, but just saying, okay, like let's say like somebody was trying to get in, okay, maybe like some other server, doesn't matter. So some other server is trying to get into your network. Okay, maybe it is using some allowed rules. Okay, but then your firewall would understand that this is I mean, this communication is not somebody is expecting. Okay, like this server has initiated a connection from the outside, and this is generally not allowed. Okay, communication from outside is generally not like allowed. I mean, it's not allowed in the sense it is not really allowed to be initiated. Somebody, of course, can allow communication from inside, and the replies are then allowed, but that is what I'm saying. So here, the firewall is aware of the context. It can understand complex communication. It can understand what is happening in the network, and then it can take those relative actions. Correct. So of course, I mean, they can take care of complex threats that way, and stateful firewalls is something that you are kind of expecting in your network, right? So of course, this kind of a thing is something that you kind of prefer, right? I mean, of course, stateless firewalls are something that you prefer, and not stateless ones, right? Stateful firewalls are something that you might want in your network. Okay, that's one of those features, right? That's one of those features. Apart from this, right? Apart from this, your firewalls maybe they would generally have proxy services. Okay, so you generally would have the firewall acting as a proxy server. I mean, of course, that is up to you whether you want to like enable the service or not. So proxy firewalls, I mean, meaning they could act like proxy servers. Basically, what this means is for your given network, okay, for your given network, it can act as your representative, like to the internet, it would seem as if you are the one who's initiating all the communication. Okay, what do I mean? So again, like a similar network. So let's say this is your inside network, and you have like your entire LAN and with like a number of devices and stuff. But when you communicate with the larger internet, okay, it is your firewall that breaks the communication here. I mean, towards your end locally, and it reinitiates a communication with the outside world. Okay, to the outside world, I mean, when they look at you, okay, from the internet, when they look at you, they do not even see your inside network. Okay, your internal network is kind of hidden, and your firewall acts like a proxy server. Okay, and that is why it is called the proxy server, right? Because they're acting like a proxy on the behalf of your local network, right? So to the internet, it would seem as if your device, okay, your device is something which is initiating the communication at your end, right? Yeah, yes, please go on.
Is the proxy server same as the DMZ or different? Proxy firewall.
Firewall could be generally it is in, see, the way it is generally deployed is in the DMZ, right? It's basically the demilitarized zone. So yeah, I mean, like you could have it deployed over there. Okay, like it's in the DMZ generally speaking. So it is beyond your internal network. Demilitarized zone basically is like outside of your like internal stuff. Basically, like DMZs in fact would even have your proxy servers and your public servers as well. Okay, so for example, and we'll have a detailed conversation on this, by the way, because when you configure firewalls, of course, you have to put them in different zones, right? But since you asked, I mean, just specifying, so DMZ is a place which is like so it's kind of where you allow communication from your public things. Okay, so this network that you see right now, I have clearly marked it as an internal thing, right? It's an inside network. But what if you had some public server that you want to be accessed, right? So this is not, so the public server, you would not be able to place it in some inside network, right? I mean, that does not really make a lot of sense, because so I hope you understand what I mean. So let's say you have this public server here, right? And maybe it provides some public services. Okay, it's your organization's public server, but this is not in your inside network. I mean, it cannot be, right? Because it would be required to kind of access by the internet, right? Placing it in the inside network would cause a lot of problems, right? As you can imagine, because like we just discussed, firewalls are not very happy with communications being initiated from the outside network. But if you have a public server, right, you would be allowing communication from outside. You have to. So you'll be placing it in a demilitarized zone, right? So it's not in your inside network. It's not exactly on the public side as well, but it is somewhere in the middle, right? So this would be categorized as a DMZ. Anyway, we'll have a deeper conversation on this when we actually configure firewalls. But yeah, this is something that is what it is, right? So demilitarized zone is outside of your inside network, right? So this public server would be kind of in the demilitarized zone as well, because you have to put it in the demilitarized zone. It cannot have a public server be placed in the inside network, right? Like I said, otherwise you would not be allowing communication inside, right? So maybe connected to the firewall, you would have a public server such as these. So yeah, you would have something like this in your network. You have to basically categorize, in many firewalls you'll have to categorize them as in different zones, right? Inside zone, outside zone, you can name them as what you want, but these are some generic names, right? So inside zone, outside zone, and DMZ are something that firewalls also kind of understand. But then again, you can name them in like in any zones as you wish. But yeah, that's basically what it is. So here the firewall could be acting like a proxy. Okay, meaning it the proxy word, of course, it simply means that it is on behalf of somebody else, right? So here in my case, it could be as like a proxy thing for my given LAN, right? It would act like a proxy server on behalf of my LAN, meaning it is something that would seem as if it is communicating on the behalf of my entire network. So these are again some services that could be provided by some firewalls. Most firewalls kind of do it again, but it depends. I mean, it depends on the firewall that you're dealing with. So basically a proxy firewall, a proxy server basically simply means that this service, again, these are services, right? When you have these services, you deploy it on some device. The device is set to behave like a server, right? But this would essentially be a service. So here the firewalls can act like a proxy, okay, act as a proxy, okay, which simply means that it is acting on behalf of a network, right? So it is kind of acting on like behalf of our inside network, right? That is basically what it means. So yeah, it kind of adds like an additional layer of security. Now, so yeah, this is also one of the things that you will find in some firewalls. That is also one of those things in the newer firewalls that you get. Newer firewalls would also have something called as content filtering. Okay, you would also have something called as content filtering. So content filtering, what is content filtering? So newer firewalls can understand the content, okay, meaning they can understand what is being sent out or received. Okay, they can understand the content, okay, meaning whether it is web traffic or whether it is email, right, with some attachments, whether this is some kind of an app. Okay, newer firewalls, by the way, can also do that. And very well-known apps, they can understand it. Okay, there's something called as, I mean, when we discuss ASA, we'll kind of discuss it. And again, in terms of firepower, we'll also discuss this back again. But they have something called as uh, application visibility. Okay, in fact, micro application visibility, where they can literally see what apps are being used even on certain websites. Okay, so for example, it's not only Facebook that you can block or allow. You can in fact even block specifically video calling on Facebook through firewalls, or maybe only audio calling, or maybe some games on firewalls, or maybe like games entirely on Facebook, for example. So they have their application visibility as well. Okay, so like I said, newer firewalls are very sophisticated in these regards, and they can understand these things. So it's well beyond the stateless mechanisms nowadays that these firewalls can behave with. So they can understand a lot of context that is going on, right? So they can understand these content filtering. They can understand some keywords that are being passed through, some web traffic, emails, applications. They can understand all of these things, by the way, right? Again, defined by rules, of course, right? Not on their own accord. I mean, of course, they work on the basis of the rules that you specify, right? Yet still, apart from all of this, uh, you have services like VPN, right? So virtual private network, and of course we'll have a lengthier discussion when the time comes when we actually discuss VPNs. VPNs is, of course, in very simple language, it is you connect to some public network securely, right? One simple example that I can give you is maybe you have your branch office one, right? And maybe you want to connect with your head office or headquarters or whatever you want to call it. And in both cases, you might have firewalls sitting on both sides, correct? And what you would be basically be doing, so let's say you want to connect through the internet, right? The internet itself is not a very secure place, so you would use your firewalls, okay, to deploy a secure connection, right? And the way this is usually done is through VPNs, okay, where you encrypt traffic. Basically with VPNs, that is what you're doing, right? You encrypt traffic, you encapsulate traffic, so that even if somebody sniffs those packets on the internet, they would not be able to read it, right? So this entire communication that goes through between the firewall that is kind of encrypted, right? That is basically like what happens. So VPN support is of course something that is offered by firewalls, and many firewalls would have the support uh, in a pretty good sense, right? Uh, and it allows for uh, securely connecting to remote sites. Okay, securely connecting to remote sites. By the way, there could be different variants of this, as we will discuss later on when the time comes. Right now, we are just kind of an overview that we are taking right now. Yet still, the newer firewalls would have something called as IPS or something called as IDS. Okay, now what is this? So newer firewalls, or they're called as NGFW, the next generation firewall. Next gen firewalls basically have something called as IPS and IDS in them. Now, what is IPS, IDS? IDS and IPS stands for Intrusion Detection and Prevention Systems. Basically, what they can do is, so I mean, of course, you're going to define some rules, correct? Yeah, fine. That is something that we always will do, right? As administrators, we will always go ahead and we'll be defining some rules on the firewalls, right? So this is, let's say, a firewall, and we define some rules that are already there on our given network, okay? And it is protecting, let's say, our inside network. Okay, fine. All of that is great. But what if you receive some kind of a traffic which is kind of a very common thing, maybe like a DOS attack, or maybe like something which is fairly well known, okay, like an attack which is kind of very well known to the world, right? And when that happens, you would have a particular trend in the traffic. Okay, you will have a particular trend in the traffic that is happening, and then the firewalls can basically detect these trends automatically. Okay, based on the data pattern that is, or the traffic that is arriving. Okay, they can understand this data that is coming in. Okay, this traffic that is coming in, that is problematic. Okay, they can basically understand that, and they will flag this off. Okay, so if it's a prevention system, the firewall will go ahead and it will block this traffic that is coming in, and which it assumes. Okay, like I said earlier as well, I use the word feel. Okay, because this is this is not a black and white thing. Okay, because it is trying to understand the traffic. Maybe it's a false flag, could be. Okay, maybe it's a false flag. Maybe the firewall thought that this is the case, but this is not the case. But yeah, if it's a prevention system, it will go ahead and it will block off the traffic. If it's only a detection system, it will detect this thing, and it will mark it as a warning, and of course the administrators would be then notified. Correct. If it's a detection system, that is what will happen. It will simply be detecting stuff. If it's a prevention system, it will go ahead and it will block the traffic, saying, no, I think this is not right. This trend doesn't seem right to me. Okay, the trend of the traffic doesn't seem right to me, and this does not seem secure and safe to me, right? So it will go ahead and so basically, all in all, some firewalls can detect and block potential threats. Okay, now this is not based on rules, by the way. Okay, so these are based on detecting trends in traffic. Okay, or the patterns. In very simple language, they detect patterns. Okay, and nowadays, I mean, with the AI and machine learning and stuff, this is this can go very well. I mean, this can be very well leveraged, right? I mean, so you have IPS prevention, of course, is just it will go ahead and prevent the thing. Actually, DS, which stands for detection, it simply will detect it and it will flag this off. So it may prevent some potential harm to your system. Again, like I said, this is about detecting trends. It may be that it is some genuine traffic, right? And the firewall goes ahead and it blocks it. Fine. I mean, like that of course can happen with anything. With detecting trends, that can always happen, right? But yeah, this feature is used for blocking potential potential threats based on patterns. And yeah, apart from this, of course, you have features like, I mean, of course, most firewalls would support, routing. You know what routing is, where the device kind of behaves like a router, right? I mean, you have those networking capacities and your networking capabilities, and of course, it understands all the routing protocols and whatnot, and it can deal with all those things, right? Meaning you can work with dynamic routing protocols and all these things, and of course, it will be able to do it. It also supports some other features like, NAT, okay, network address translation. Again, this is something that usually routers do in terms of IP services. NAT is basically like a translation service, right? Again, something that usually the routers kind of do, and you would usually deploy this on a given router. But I mean, yeah, since it is generally the firewall that is sitting on the edge of your network, you might want to deploy NAT on the device, right? I mean, your firewall, right? So you want to deploy NAT on maybe the firewall because it's sitting on the edge of your network, right? This is the first thing that comes into the picture, right? Similar, like, and this is a very good example, by the way, that we just made up, right? So as you can see here, you have this public server, right? Which is in a demilitarized zone, and you have the firewall here. Possibly for your internal stuff, this public server would have uh, a private IP address, okay, so that your internal network can work, with your with your DMZ server, right? So within your private network, you can work with your private IP addresses, but when people from the internet try to reach your public server, of course they'll be using public IP addresses, right? So there needs to be some kind of a NAT service, by the way, right? As you can imagine, so there has to be of course some NAT service, okay, which will be running some NAT service, which will be running on your firewall, by the way, and that will be doing all the translations back and forth between your public server and the internet, and even with your like clients and stuff, right? So NAT is also something which is there, and which can be done on your devices. So this translation of private IP addresses to public and back and forth is something that uh, is of course something that you need to have on a firewall. And finally, of course, after all of this, what you will probably have is all the logging mechanisms, right? Because you need to log these stuff, right? So whatever's happening on the firewall, maybe it needs to be investigated later on. Maybe you want to check for trends, or maybe it's general I mean, like general trends that you want to keep track of, right? So logging and reporting, of course, is always also a part of this business, right? And you would have mechanisms that firewalls would have to help you, deploy these things, correct? So NAT is something which is there. Logging and reporting is something which is always there, and they always have some logging capacities. That so basically, this is all about recording stuff. Okay, so they'll keep a record, and of course, you will have to tell the firewall what to record, because there's a lot of monitoring and a lot of activity that is going through the firewall. You might not want to have everything being logged and everything being stored based on your database requirements, but yeah, I mean, like, you want to record stuff, and you also then want to be able to export and report stuff, right? Whenever the time comes, of events, of activities that are happening, maybe based on patterns, troubleshooting, and also, of course, you have to, as administrators, of course, you would be required to print out reports and produce before the compliance authorities, right? That is always a compliance thing with uh, with organizations, and particularly with security, and you'll have to uh, do that, right? You'll have to submit reports for compliance things, that you have complied with some certain policies, and your devices are configured in a certain way, and things like that. But yeah, maybe these are some generic features. I mean, there are some more other things that I would want to discuss, but let's keep the discussion to this point at this point in time, and we'll discuss more, of course, on this regard, and then we'll start off with the actual ASA device, and of course the practical part of it as well.